To compromise the victim systems, we prepare some malicious software and force the victim to run the malware into their systems, so we can open a back door or steal some data or gain a session, etc. Before talking about the customer payload creation, we need to see a few terms to make the subject clearer. Most likely you already know the terms we'll talk about in this slide. If so, just jump to the next one. Malware. It's a short form of the term malicious software. It's a kind of software that's used to compromise the computer systems. It's an umbrella term used to refer to a variety of forms of hostile or intrusive software, including computer viruses, worms, Trojans, ransomware, spyware, adware, scareware, and other malicious programs. It can take the form of executable code, scripts, active content, and other software. Payload, inside malware, is the portion of the malware which performs malicious action. Metasploit framework is one of the most known terms in the cybersecurity domain. As the open-source sub-project of the Metasploit project, Metasploit framework is a tool for developing and executing exploit code against the target machine. Even though they're deprecated and removed from Metasploit framework, I'd like to talk about MSF payload and MSF encode first. They're deprecated because their abilities are collected into a single tool, MSF Venom. To understand what MSF Venom does, it's better to talk about MSF Payload and MSF Encode first. MSF Payload was a command line tool that's used to generate and output all the various types of shellcode that are available in Metasploit. Using MFS Payload, you can create an executable file, as well as creating a payload to embed the file. The parameters displayed in the slide give us some more about what the MSF Payload does. Most of the time, one cannot simply use shellcode generated straight out of MSF Payload. It needs to be encoded to suit the target in order to function properly. This can mean transforming your shellcode into pure alphanumeric, getting rid of bad characters, or encoding it for 64-bit target. It can also be instructed to encode shellcode multiple times. Output the shellcode in numerous formats, C, Perl, Ruby, and one can even merge it to an existing executable file. So most of the time, this tool was used in conjunction with MSF Payload. MSF Venom is the Metasploit's standalone payload generator. It's the combination of MSF Payload and MSF Encode, putting both of these tools into a single framework instance. That means MSF Venom is a combination of payload generation and encoding. You can do everything that you can do with MSF Payload and MSF Encode. You can generate a payload, encode the payload, avoid the bad characters, use a custom template, and more. Let's see how we can create a basic malicious Windows executable using the MSF Venom tool. 64-bit Windows 8 is the victim system. Choose an executable to use as a template. The output malware will be the same size with this template file. I'm going to use putty.exec file as the template. Let's copy putty.exec to Kali to work on it. First, look at the IP address of the target machine here, Kali. You can use WinSCP tool to transfer a file from a Windows system to a Linux system. SCP, Secure Copy, is a means of securely transferring computer files between a local host and a remote host, or between two remote hosts. It's based on the SSH, Secure Shell Protocol. Now, since WinSCP uses SSH protocol, you'll be sure the SSH service is running on Kali. Check the status of the SSH service using service SSH status command. It's already active on my Kali. If it's not running, use service SSH start to start the SSH service in your Kali machine. If you try to log in WinSCP using root user, you may see the access denied message. That means using SSH service with root user is denied in your Kali machine's SSH service configurations. Either change the SSH service config to be able to connect with root user or create a new user to use SSH connections. I choose to create a new user. You can use add user or user add commands on the terminal screen, or users interface to add a new user. Now, I've already added a user before SSH user for this purpose. You can add a similar user to your system. Connect WinSCP using SSH user credentials. Find the exec file at the Windows side. In this example, it's on the desktop of a current user. Copy it to the Kali machine, in here, to the home folder of SSH user. In Kali, use is command in the terminal screen to see if the file is transferred successfully. Now we're ready to create a malicious executable using the putty.exec file as a template. Prepare the appropriate MSF Venom command. The first parameter is -p, which specifies the payload used. You have to find a correct payload according to your target. Don't forget to choose a payload with the correct platform, correct architecture, correct connection method, etc. You can see the available payload using MSF Venom-L payloads command. There are a lot of payloads available, and since the target machine is 64-bit, we can filter the results using grep command with pipe. We use the Windows/x64/meterpreter/reverse_TCP payload for this example. Let's have a pause here and have a small introduction to the world of Metasploit. Metasploit project is the most used penetration testing framework in the world. It can be used to test the vulnerability of computer systems or to break into remote systems. Metasploit was created by H.D. Moore in 2003 using Perl. By 2007, the Metasploit framework had been completely rewritten in Ruby. In 2009, the project was acquired by Rapid7. Now they have a free and open source version, Metasploit Framework, and a commercial version, Metasploit Pro. Its best-known sub-project is the open source Metasploit Framework, a tool for developing and executing exploit code against a remote target machine. The MSF console is probably the most popular interface to the Metasploit Framework, MSF. It provides an all-in-one centralized console and allows you efficient access to virtually all of the options available in the MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you will learn to appreciate the power of utilizing this interface. Meterpreter, short for the Meta Interpreter, is an advanced payload that is included in the Metasploit framework. Its purpose is to provide complex and advanced features that would otherwise be tedious to implement purely in assembly. The way that it accomplishes this is by allowing developers to write their own extensions in the form of shared object DLL files that can be uploaded and injected into a running process on a target computer after exploitation has occurred. Meterpreter and all of the extensions that it loads are executed entirely from memory and never touch the disk. Let's continue to create a malicious executable using the MSF Venom tool. Now, the first parameter was the payload. We can choose the platform here, Windows, but since we chose a Windows payload, the tool will already understand the platform. Same as the platform, we can set the architecture x64 using the -arch parameter. Because we use a payload for x64 architecture, the tool will already understand the architecture, so we don't need to use arch and platform parameters in this example. The next parameter is -f to determine the format of the output file. Now you can use MSF Venom -help -formats to see the available formats. We only use the exec in this example. Then specify the template file using a -x parameter with the template file. Name the output file with the -o parameter. Now is the time to define the options of the payload. To see the options of the payload, you can use the -payload-options parameter with the payload. We have to define the L-host and the L-port options of the payload here. Complete the command again, output file format, template file, and output file name. Now assign L-host and L-port options of the payload. L-host is the IP address of the listener machine, in this example, our Kali machine. L-port is the port which will be open to listen to the sessions. Hit Enter to create the malware. As you see, no arch is selected. The tool selected x64 from the payload, and no platform is selected. The tool automatically selected Windows from the payload again. To be sure, go to the folder and see the created malware. The attacker should find a way to make the victim accept and run the malware. Let's just copy the malware to the victim's machine at the moment, and suppose that we send it as an attachment to a phishing email. First, let's try to copy the file to the Windows machine while Windows Defender is running. As you can see, Windows Defender recognized the malware. And deleted it in seconds. Can you guess why? Because we used a standard Metasploit payload which is very well known, and Windows Defender recognized it easily. To see the payload in action, let's turn Windows Defender off and send the malware again. As an attacker, we need to listen to capture the sessions of the victims who run the malware. Start MSF console. You'll have a Metasploit framework shell. Search for the handlers. Use exploit/multi/handler for this example. In Handler, we have to use the same payload that we use in the malware. List the options with Show Options command. Set the listener address and port. Since the default port is the same with the port we assigned in the malware, we can leave it as is. And run the handler, it starts to listen at that moment. Now go back to the victim machine and run the malware. Voila! We got the session from the victim machine. Look at the system info using sysinfo meterpreter command. It's a 64-bit Windows machine. Look at the user ID. Meterpreter has a lot of excellent commands to compromise the victim's machine. Use help command to see some of them. Let's take a screenshot of the victim machine. When we list the currently running processes using task list command in the victim machine, we see the malware running. You can kill it using the task kill command with /PID parameter. Use /F parameter to force it to be killed. As soon as the malware process is killed, the Meterpreter session dies as well. Using MSF Venom, you can create more complicated malware. Doing this, you may suppose it will not be easy for the security systems to recognize the malware. Look at the examples seen in the slide. You can use -E parameter to encode the payload. You can use MSF Venom-L encoders to see the list of encoders. With the -I parameter, you can encode the payload several times. In this example, it was 10 times. -K is used to preserve the template behavior and inject the payload as a new thread. If you use this option, the size of the output file becomes a bit bigger than the template file. But do not forget that you are still using a standard Metasploit payload. Let's take a closer look at the listener. If you use a payload with a reverse connection, also known as a connect back, you, the attacker, have set up a listener first on your box. The victim or target machine acts as a client connecting to that listener, and then finally you receive the session. Exploit/multi/handler module of Metasploit framework is used to collect and manage multiple sessions from different platforms. You can see the detailed options of the handler using show advanced command. If you set exit on session false, the handler continues to listen when an active session is killed. Set the same payload with the malware and set the option of the payload. If you run the handler using the exploit-J command, the handler runs in the background. When a session is opened, a message appears. Use session-L command to list the active sessions. To activate a session, use session-I command with the ID number of that session. You can use background command to send the session background. Use session-K with session ID to kill a session. If you use -K uppercase K parameter, you kill all captured sessions. Creating custom payloads. The payloads of well-known frameworks such as Metasploit are easily recognized by the security systems. The best way to avoid this is to create your own payload. There are open source and free tools to create your own malware and payloads such as Veil, Avoid with a 0 instead of an O, Syringe, TheFatRat, and Empire. Now you will see how to create a custom payload using Veil framework. First, let's install it to our Kali machine. If we Google as Veil evasion, the first link will be the GitHub page of Veil evasion. This page redirects us to the GitHub page of Veil 3.0. In the README part of the page, we see the quick installation guide. We simply follow the steps of this installation guide. Install Git if it's not already installed. Create the clone of the Veil 3.0 project. Go to Veil folder. Under the setup folder, run setup.sh script with the -C parameter. And this will take a few minutes. In this period, some install wizards are opened. Don't worry, they're all next finish wizards. Now, let's see the Veil framework in action. Go to the Veil folder and run veil.py script. Use list command to list the available tools. We would like to use the evasion tool, so print use one and hit enter. Veil evasion menu is opened. Use the list command to see all available payloads. There are more than 40 different payloads. Let's use Meterpreter payload, which is using a reverse HTTPS connection. Copy the file name with the full path. We'll use it on the next step. Print use 27 to use the payload we selected and hit enter. The options of the payload are listed. Change as many options as possible to make the payload more customized. The most important options here are the address and port number of the listener machine, lhost and lport options. Again, listener will be our Kali machine, so assign the IP address of Kali as lhost. Let the lport remain as 4444. To keep the example simple, I'm not going to change any other option at this point. Now we're ready to generate the payload. Use the generate command for this purpose. Give the base name for the output files. To be more meaningful, I'd like to use connection type reverse protocol HTTPS and the port number that uses 4444 in the file name. And last, it's asking the method to create the executable file from the script code. Choose the first one. Malware is ready as a code and as an executable file, plus an RC file which is used to start an appropriate handler that uses the same options with the malware as prepared. Let's transfer the malware to our victim machine using the WinSCP tool. First, I copy the malware to the home folder of the SSH user. You can examine the generated file using Linux file command. Yes, it's Windows executable. Now, go to the victim machine, run WinSCP, and connect to the Kali machine with SSH user. Before copying the malware generated by Veil, let's turn on Windows Defender. Now, while Windows Defender is running, copy the malware to the victim machine. No, Windows Defender cannot recognize the malware. We successfully copied the malware into the Windows 8 system. Now, at this point, as the attacker, we need to have a listener because the payload of the malware uses a reverse connection. So go to Kali, use Metasploit RC file, which is generated by Veil, to create a listener. Print MSF console-R and add the RC file name with its full path, then hit enter. An HTTPS reverse handler starts on our Kali machine's 4444 port as background job. Now go to the Windows machine and run the malware. A session is opened. Use the sessions-l command to see the open sessions, and the sessions-i1 to enter the open session. Now we have a Meterpreter session on the victim machine, even though the victim machine has a security solution, Windows Defender. Enjoy. Another powerful and easy-to-use tool is TheFatRat. It's an exploitation tool that can help you to generate backdoors and post-exploitation attacks like browser attack DLL files. This tool compiles malware with popular payloads, and then the compiled malware can be executed on Windows, Linux, Mac OS X, and Android. Because it's not embedded into Kali, we need to install the TheFatRat first. At the beginning, we need to download the files of the TheFatRat framework. Clone the Git account of the TheFatRat for this purpose. Wait until the cloning is finished. That may take some time according to your internet connection speed. The files are cloned under the TheFatRat folder. Go into the folder using the cd command. Look at the files using is. Let's run the TheFatRat shell script. Oops, permission denied. Look at the file permissions. Probably it does not have the executive privileges. True. No execute write at all. Make the TheFatRat file executable using chmod, that's chmod, Linux command. Now it has execute writes for all. Now we can run the TheFatRat script. It says we have to run setup.sh script first. We're not going to run setup.sh script all the time, it's just needed to run before the first usage. Like the TheFatRat file, setup.py file does not have execute privileges. Make it executable as well. And run. It installs all the dependent tools necessary for the TheFatRat tool and upgrades the tools. There are a lot of tools that the setup script checks if they are installed and up to date, so be patient. Don't be anxious. Installing tool dependencies. Updating Kali repo. Installing MingW32 compiler. At the end of the setup, it asks if you want a shortcut for TheFatRat in the system. That means the setup will add TheFatRat into the path, so you'll be able to run it from anywhere in your terminal. Now we can run the TheFatRat script. It checks all the dependencies at the beginning. It warns us not to upload the output files to VirusTotal. We already know the reason. It shares the files with the antivirus companies. Instead, you can upload it to nodistribute.com to test if it can bypass the antivirus systems. Now we're ready to use the TheFatRat. Let's try to create malware which cannot be detected by the security systems. I'd like to try to create a backdoor with the MSF Venom first. Go to the TheFatRat folder and run TheFatRat script. If you let the tool add a shortcut to the system, you don't need to go to the TheFatRat folder. You can run it from anywhere. It checks all dependent applications and conditions, such as internet connection, at the beginning. Don't upload to VirusTotal warning. Okay, there are several different methods to create backdoors using the TheFatRat. You can create backdoors here using MSF Venom, Foodwin, Avoid, PWN wins, etc. In addition, you can add backdoors into the original Android APK packages. Let's create a malware with a backdoor using the MSF Venom in this example. Type 1 and hit Enter into the main menu. MSF Venom Creator Module menu appears. Now, since our victim's machine's operating system is Windows, I chose here the second option in this menu. It first gives me the IP information of my local machine, then asks for the listener IP address. Thanks for the kindness. Since I use this machine as the listener, I enter its IP address. Asking for the listener port, I'll choose 5555 for this time. Now it wants me to enter the base name for the output files that the tool is going to generate. While trying to find the correct payload and malware, you may need to try a lot of different options. So to be able to recognize which file I generate for this time, I use the day of the month and the time in file names. For this example, since today is the first day of the month and it's 2255, I use 01-22-55 as the file name base. Next step is to choose the payload. Let's choose Windows/meterpreter/reverse_TCP, number 3. It uses almost all facilities of MSF Venom. It encodes the payload with 10 iterations, with Shikata_GA_NAI encoding method first, then encodes with another method 8 times, and 3 other encodings follow. The malicious executable was created. It's in the output folder under the TheFatRat folder. Now, let's go to the victim machine and transfer the file using WinSCP. Connect to your Kali machine. Remember, SCP protocol uses the SSH, so be sure that the SSH is running in Kali. My Kali's SSH is serving from 443. Don't ask why. Okay, we connected. Go to the folder in where our file is. Root, TheFatRat, output, and here it is. Drop it and drag to the desktop of the Windows system. But first, let's start Windows Defender and see if our malware is able to avoid it or not. Okay, it's already running. Now let's transfer the malware into the Windows system. Oops. Our malware is detected by Windows Defender and deleted in a few seconds. Anyway, there are always some computers which do not have any security protection. Let's examine our malware if it works on them. Go to Settings, Administrator pane, and uncheck the Turn on this app checkbox to disable Windows Defender, and press Save Changes. Now, drag the malware again and drop into the desktop. For running the application in the victim machine, let's think about the hacker side. Are we ready as a hacker? What do we need to connect to the back door if the malware succeeds? Well, sure, we don't have a listener at the moment. Go to Kali machine to start a listener. Start Metasploit Framework console using MSF console command. While Metasploit Framework is starting, I look at the information of the backdoor in the terminal where I create it to make sure the payload is the one I used. Why? Because I have to use the exact same payload while creating the listener. MSF started, type use exploit/multi/handler first. And then set the payload that we used in the malware. Look at the options using the show options command. Set the lhost. Again, I use the information of the malware. Set the port, which was 5555 on my malware. Now type exploit to start the handler. Go to the victim machine now and run the malware we copied a few minutes ago. Turn back to Kali, you see that a Meterpreter session is opened. Once again, the victory is ours. But wait a second. Windows Defender and Windows 8 has detected our malware. We should find another way to create an undetectable malware. This time, I'd like to create a malware using PWN wins, the option 6. We are now in the main menu of the TheFatRat tool. Type 6 and hit Enter to use PWN wins to create the malware at this time. PWN module menu appears. There are different options here to create an exec, batch, or PDF file. I'd like to use the second option to create an executable malware. Now, when I type 2 and hit Enter, it gives the IP information of my system and asks for the listener host. Enter the L host, the IP of your Kali, and L port. This time I use 6666. Use whatever you want. Base name for output files, I use the same format, 01-23-02. Again, I choose the third payload, reverse_TCP, the backdoor is saved to the output folder. Now let's go to the victim machine and transfer the file using WinSCP. The Kali side of WinSCP, we're in the output folder of the TheFatRat application. Before transferring the new malware into the victim machine, be sure that Windows Defender is running. I open the Action Center and turn on Windows Defender. Okay, it's running. I can transfer our new malware now. No, not again. Defender detected our new malware as well. Well, we should try another method. The TheFatRat is very powerful, and I'm sure we can find a way to bypass the Defender. I'll try another method if PWN wins, the sixth option of the main menu. This time, I choose the fourth option in PWWin's menu. I'll again create a malicious executable with a different method. Inputs are all the same. L host first, then L port. I choose 7777 this time, and the base name of the output files. I chose the reverse TCP as the payload, the third option. And done. The output file is created. Let's go back to the victim machine, refresh the Kali side of WinSCP, and drag the newest malware and SROP into Windows Desktop. As you see at the lower right-hand corner, Windows Defender is running, and it couldn't detect our malware this time. Well done. We overcame it with the first problem, bypassed the security system. Now, the main question is, does the malware work? I mean, do we have the back door? So at this point, we go back to Kali and start a listener. Start the MSF console. Type use exploit /multi/handler to use the handler. Set the payload, the same one we used in the malware. To be sure, I prefer to copy the payload from the TheFatRat terminal and paste it. Set lhost, the IP address of Kali, and lport. Remember, that was 7777. I want to look at the open ports using netstat-tnlp Linux command. 7777 is not in use at the moment. Back we go to MSF Console's terminal and type execute to start the handler. Go to the Windows machine and run the malware by double-clicking on it. Back to the Kali machine, and a new Meterpreter session is open. Now we can say, victory is ours. You may face some problems while installing a new tool. I'd like to show you what to do simply on an example case that I faced during the installation of the TheFatRat tool. When I installed and ran the TheFatRat, it gave an error message and I couldn't run the tool. Looking at the logs of the TheFatRat, I saw the error message that says no module named names. Honestly, I have no idea what that is. I opened the Google and typed the TheFatRat no module named names. Clicked the first link, which was the issues page of the GitHub account of the TheFatRat. I did what the Bettercap said and overcame the problem. Embedding malware into the documents. It's very common for malicious software to be embedded in a widely used document, such as a PDF or Office document. Let's look and see what Metasploit framework has for this purpose. In MSF Shell, and you already know how to open the MSF Shell, simply type MSF console in the terminal screen of Kali. If you search for Adobe in PDF words, you see that Metasploit framework has 2 exploits to embed a malware into a PDF file. And thankfully, the ranks of the exploits are excellent, which means they will work very good and stable in the ideal circumstances. Of course, you need an appropriate payload for the exploit. When you look at the options of the exploit using Show Options command, you see that the target of the exploit is Adobe Reader with versions 8 or 9, which is running Windows, XP, Vista, or 7. When you gather information about the target company, you'll probably find this information: which operating systems are used, which readers are preferred, which versions are used, etc. Suppose that you don't have any clue that the target operating systems and/or readers are used in this company. Still, isn't it worth it to try? Now is the question: can you find any device running an old version of operating system and an old version of the reader? The answer is of course. Do you remember the WannaCry ransomware attacks? The attack affected more than 300,000 computers across 150 countries, including the UK's NHS health systems. The malware was using a vulnerability where Microsoft had already released a patch for it 2 months before the WannaCry attack. But the attack affected hundreds of thousands of computers because they are always out of date. If you can find a few machines that fit these conditions, it might be enough for you to hack the entire company. The next step is to set the options. Set the template PDF file in file name. If you don't, Metasploit framework will use its own template. Set the output PDF file name. If you don't, Metasploit framework will name it as evil.pdf. Now set the options of the payload you choose. If you choose a reverse HTTPS interpreter payload like me, set the IP address of the listener, lhost. Set the listener port if you don't want to use the default one, lport. And when you're finished setting your options, you can use exploit or run commands to generate the file. Now you must bring the file and computer users, victims, together. Send the file in a phishing email. Copy the file in flash drives and give them as gifts. Write the file in CDs and spread them in the company if you can, etc. By merging a malicious PDF with another arbitrary PDF file, you can make it more difficult for antiviruses to recognize it. In the first picture, a Windows/Meterpreter/reverse_TCP payload embedded PDF file is scanned in virustotal.com. No obfuscation or customization was performed, so 30 of 47 antivirus programs detected it. In the second pic, a custom payload using Windows/Meterpreter/reverse_HTTPS payload of Metasploit was created by Veil and embedded into the PDF file. 17 of 47 antivirus programs detected the malware. In the third picture, the document used in the second picture was merged with a clean PDF file. In this time, only 10 of 47 antivirus programs detected the malware. Just like embedding a malicious code into a PDF file, you can easily embed a malicious macro code into an MS Office document such as MS Word. To create a malicious Word document, we should prepare a macro code and the payload which is used by the macro. Let's prepare a malicious Word document using the Metasploit framework and Veil framework. The steps of this example will be creating a malicious executable, converting the malware into a macro code which is ready to be embedded into an Office document, creating the Office document, embedding the script code as a macro, and concatenating the payload as text. Starting a listener to listen to the sessions of the victims who open the Office document. Opening the document as a victim. Collecting the session as the attacker. Now let's do it. First, create a malicious executable using Veil. I'll take it faster now because we've already done this before. To remember, please refer to our Creating Custom Payloads with Veil lecture. Choose List in the main menu. Type Use One to use Evasion tool. Type List to list available payloads. Let's use payload 27. Setting the listener host is enough at the minimum. And generate. Give the name initials for the outpost files. Choose the executable creation method. Okay, malicious executable is created. Let's test our malware to see if it's working. Transfer the file to the victim machine. Now here I have a Windows 8 system as victim. I'm going to use the WinSCP tool to transfer the file. And of course we have to find a reasonable way to do it. Phishing, malicious website visit, etc. Copy the malware into the SSH user home folder for ease of use. Run WinSCP. Connect to the Kali machine. And transfer the file to the Windows desktop. Start a handler to collect the session. Go to Kali and start the MSF console with the -r parameter and use the RC file produced by Veil. Handler started is at the background. With the session-l command, we see that no session is in progress at the moment. Run the malicious executable in the Windows system. We now have a valid session of the Windows system. Use the sessions-i session ID command to interact with the session. Our malware is working like a charm. Now let's kill the session for now because this was just a test if the malware is working well. Sessions-k, uppercase K, will kill all the open sessions. Now we'll create a Visual Basic script using our malicious executable file. We're in the Kali machine, so find the location of the exec2 VBA script using locate command in Linux. Go to the folder. And run exec2 VBA Ruby script. Now the script needs two parameters to run. First, the malicious executable with full path, which will be converted to a macro code. Second, the name of the output file. The script is created. Now is the time to create the malware embedded Word document. Go to the Windows machine, which is the system of the victim, and transfer the microfile using WinSCP. Let's open the .vba file using a notepad. Now, I'm using Notepad++ for this purpose because the .vba file is a bit big and Notepad++ has a much better memory management than the native Notepad application in Windows. There are two parts in the .vba file. The first part is a macro code. The second part is the payload that will be used by the macro to create the meterpreter session. Now start using MS Word and create a new Word document. By the way, do you wonder why I use Windows 8 and Office 2013? Because I have their licenses and no others. Create a macro. Under View tab, select Macros, View Macros, give a name, and click the Create button. I'm using the Word application of Office 2013. If you use a different version, your menus might differ. Please Google it to find the location. Open our .vba file and copy the macro code part and paste it into macro code page. Save the changes and close the page. And we have malicious macro codes inside the document. Now we still have to embed the payload into the document. Go to the .vba file, copy payload data part, paste it into the Word document. We have quite a big payload, and I confess it's bigger than I expected. This is because we used Veil to create a custom malware, and we chose Meterpreter, which is a complex one. Wait until the paste is finished. It could take 15 to 20 seconds. To make the document seem like a regular document, you can shrink the font size, for example, and make it 1. And you can make the font color of the payload white. Then save the file. To succeed in this attack, MS Word application has to be configured to run macro codes. In MS Word, all macros are disabled by default, so you have to convince the victim to enable the macros as well. In File menu, select Options. Select Trust Center. Click Trust Center Settings button and tick Enable All Macros option. Click OK at the lower right corner. Now we have a macro-enabled MS Word. Be sure the handler is running at the moment. Open the Word document we created. It may take some time because the document is a big one. Go to Kali. Wait a few seconds. You'll have a new session for the victim system. Congratulations. Another way to compromise the target systems is to send the malware as a browser add-on. You can use Metasploit framework to prepare malicious Firefox add-ons and serve them from a server. Select the exploit and the payload, then set the options. When you run the exploit, it starts a handler as well as an application server to release the add-on. As soon as the victim allows you to install the add-on, you'll have a session of his or her system. Let's see how to prepare and use malicious Firefox add-ons. In Kali, start the Metasploit framework using MSF console command in the terminal screen. If you do not necessarily know the exact name of an exploit, you can use search command to find it. Use the exploit with the use command. List the payloads that you can use with this exploit. Show payloads. Let's select a shell payload with a reverse TCP connection. Now look at the options of exploit and payload using the show options command. Server host is the server where an application server will be started to serve the add-on. In this example, it's our Kali machine. Server port is the port that the web application is served. You can choose 80, which is the default port of the HTTP protocol. URI path is the path of the payload. Now set the options of the payload. Listener host, again, our Kali machine, is in this example. Listener port is 4444 by default. You can change it if you want. Now we are ready to run the exploit. When you run the exploit, a reverse TCP handler on port 4444 and an application server serves on port 8080 is started. Let's test if the application is alive. Copy the URL and paste it in the address bar of the browser. It seems everything is okay. In Windows System, which is the system of the victim, run the Firefox. This is the Firefox version 57. Now we're going to send a phishing email which contains a link to the add-on we prepared. In this example, I used the yopmail.com service to send the phishing email to the victim. Yopmail is the disposable email address service which does not require a sign-up and provides access to any email address in the form of any name you want at yopmail.com. In the attacker system, Kali, prepare the phishing email and send it to the victim. The victim opens the email in his or her Firefox browser, which is the latest version. When the victim clicks the link, a warning message which says, "Firefox prevented this site from asking you to install software on your system," appears. If you click the install link directly in the website, nothing changes. You're not allowed to install the add-on. Starting from version 41, Mozilla decided to allow plugins only if they're signed and verified by Mozilla. But don't worry, you'll probably find systems that use Firefox older than version 41. Let's repeat our test with an older version of Firefox. Download an earlier portable version of Firefox. I chose version 46 for this example. Install it and run. You are now using Firefox version 36. Go to the mail service of the victim. When you click the link, Firefox again prevents the site to ask to install software. In this time, though, clicking the Allow button brings you to the software installation window. Click the Install Now button, you see the message that the installation is successful. Go to the listener now, which is our Kali machine. Looking at the listener terminal windows, you see that a session on the victim's computer is open. Go to the session using session-i-session-id command. Now, because we used a shell payload, we have a shell session at this time, not a meterpreter session. And we can use all the commands of the victim's computer. Since it's a Windows system, we can use Windows commands right now. Directory to list the files of the current folder. Who am I to see the active user. ipconfig to see the IP addresses, etc. The first question, what is PowerShell? To give you a better understanding of PowerShell, we should first define what a shell is. In computer science, a shell is a user interface that gives you access to various services of an operating system. A shell can be command line based, or it can include a graphical user interface or GUI. Windows PowerShell is a shell developed by Microsoft for purposes of task automation and configuration management. This powerful shell is based on the .NET framework, and it includes a command line shell and a scripting language. Why PowerShell? PowerShell is a very powerful tool that offers tremendous benefit for querying systems and executing commands, including on remote machines. However, it's easily used for malicious purposes because it falls under the radar of traditional endpoint security products. PowerShell gives the bad guys a lot of power because it's part of the native Windows operating system, which makes it difficult for security teams. What is Empire Project? With their own words, Empire is a pure PowerShell post-exploitation agent built on cryptologically secure communications and a flexible architecture. Empire implements the ability to run PowerShell agents without needing PowerShell.exec. Rapidly deployable post-exploitation modules ranging from the keyloggers to mimikatz and adaptable communications to evade network detection all wrapped up in a usability-focused framework. Since the Empire project is not embedded into Kali, we need to download and install it. PowerShellEmpire.com is the official site of the team who created the Empire project. It's a very handy website full of documents and demos. However, as of this video capturing, it's in its early days of 2018. The documents need to be updated according to the latest version of Empire project. The link at the bottom of the homepage, Get Empire, brings you to the GitHub page of Empire project. I recommend you read the README section of the page for details. From the clone or download buttons at the upper right, copy the URL to clone the project. Open a terminal window, write git clone, paste the URL, and hit enter. Now the files of the Empire project are being downloaded to our local. When the download finishes, go to the Setup folder under the Project folder, Empire, using cd Linux command. Run /install.sh. The project and all the required packages are being installed in this moment. Be patient. It could take a few minutes. Now it asks for a password to negotiate with the server. You can enter a password, or if you hit enter directly, it'll generate a random password for you. As soon as you hit enter, the setup is complete. Now use the cd Linux command to go back to the project home folder. And type /empire to start the tool. Welcome to the Empire. Let's see the Empire in action. Empire has its own shell-like command line interface. As of this video capturing, Empire has 282 modules. First, let's start by typing the help command to display the help. Now I'm going to show you how to use Empire project step by step. First step, create a listener. Listeners in Empire are the channels which receive connections from our target machines. It's similar to the listeners in Metasploit framework. Before we do anything in Empire, we need to start the listeners. Type listeners to enter the listener management state. As you see, the shell prompter changes as Empire:listeners. Once we move to the listeners management state, we can see its options by typing the help command. Let's take a look at some of the commands of the listener state. Info is to display information about the active listener. Now you think it's the same as the show options command of Metasploit. Kill is to kill a particular listener. List is to list all the active listeners. Use listener is to use one of the listener modules of Empire. Use stager is to use one of the available stagers. We'll see that on the next step. Let us now look at how to start a listener module in Empire. Type the use listener command, put a space character, and press tab twice to see the listeners available in Empire. There are 7 different listeners listed. Let's use the HTTP listener as an example. Type use listener HTTP and press enter. Now the same as with the Linux bash, you can use the tab button to complete any particular keyword. Here, press tab in the middle of the word instead of writing the entire word. Again, the shell prompt has changed as Empire:listeners/HTTP. Help command now displays the commands of this state. As you see, some of the commands are the same with the previous menu, but there are some different commands here. The info command shows the options of the particular type of listener we want to start. The set command is used to assign the values of the options. Similarly, the unset command is used to clear these values. Every listener requires certain options to be set. For example, when you run info command, you see that the HTTP listener needs the host and port values to be configured. An important warning here, in Empire, commands are case sensitive. That means if the name of an option is name with an uppercase N, you have to use its exact same style. Name with a lowercase has a different meaning for Empire. Default values are set for the options. IP addresses of your current system is set as the host, and 80 is set as port. The default name of the listener is set as HTTP. Change the values if you want using set command. I want to change the listener name as my HTTP listener. When all options are set, we can start the listener using the execute command. When we go back to the main menu using the main command or back command twice, we see that we have now one active listener. The second step is using stagers. Now, in here it's better to explain the stager and stage concepts of the exploitation world. Stagers set up a network connection between the attacker and the victim and are designed to be small and reliable. Stages are payload components that are downloaded by stager modules. The various payload stages provide advanced features with no size limits such as interpreter, VNC, injection, or shell. Stagers in Empire are used to set the stage for the post-exploitation activities. They're similar to payloads, which are used to create a connection back to Empire. Type use stager, put a space character, and press tab twice to see all of the available stagers. Let's start the launcher stager as an example. A stager will generate a command ready to launch in command line terminal CMD. Type use stager multi/launcher command to load the stager. Shell prompter changes as the name of the stager we chose. If you type help now, you see the commands of the stager state. Use generate or execute to generate a stager. Set and unset to set and unset values to particular options. Interact to interact with a particular agent which is normally used when there are multiple listeners. Type info to see the information about the stager and the options to be set. Now let's set the options to be able to generate the stager. We need to set a listener in order for the stagers to be able to communicate with Empire. In the last step, we already created a listener. Let us set this listener for our launcher stager. Type set listener my HTTP listener for this purpose. If you gave another name to your listener, use that instead of my HTTP listener. And once again, don't forget that Empire is case sensitive. Leave the other options as default for now. Run execute or generate command to generate the stager. The stager has created a command ready to be launched in the command line terminal. The third step, using agents. When we set the stager to our target system and the machine engages with it, we get a reverse connection back. This is known as an agent. In our example, let's run the generated command into the victim's command line terminal window. Now, there are a few different methods to start a terminal screen in Windows OS. You can press Windows plus R to start the Run dialog box, type Command in the dialog box, and hit Enter. Or you can type Command CMD in Windows Start menu. Windows will find you the tool. Or you can try to find the Command Prompt tool inside the All Applications menu, which I honestly don't remember. Copy the generated command, paste it in the command prompt of the victim's system. Command prompt disappears when the command is executed. Go back to Kali. As you can see, we have a new agent. Type main to go back to the main screen of Empire. We see that we have an agent. Type agents to go to agents. Use interact command with the agent ID. You're now in a session of the victim system. Type help to see the commands you can use. For example, type info to see the entire information of the victim system. Or type SC to take a screenshot, etc. Okay, let's have another example in the Empire project. This time we're going to create a macro to prepare a malicious Office document. At this point, we already have a listener, so I jump to the stager generation step. Type use stager, put a space character, and press tab twice to see all of the available stagers. Now we'll use Windows macro to create a macro which will open a back door into the victim's machine. Type use stager Windows/macro and hit enter. Type info to see the options. We have to set the listener. Now type set listener my HTTP listener, or if you gave it another name to the listener, type it. Leave the other options with the default values. Run execute command to generate the macro. The macro is generated in the temp folder, TMP folder, with the name of macro. Let's go to the temp folder and look at the file using cat linux command. Select and copy the macro code. Now it's time to create the malicious Office file using this macro code. We're now in a Windows system. I'm going to create a Word document. Open a new document from the View tab. Open Macro window. Paste the macro code that we copied in Kali. Save and close the macro window. If the macro code is not in the clipboard of your victim Windows machine, if you cannot paste the macro code in Windows system, copy-paste action may not be allowed by your virtualization platform, VMware, VirtualBox, etc. Don't worry, there are lots of ways to bring the macro code in. For example, you may change the configuration of your virtualization environment to allow copy-paste between the virtual machines. Another method is sending the code to yourself in an email, so you can open the email in the victim's machine and copy the macro code. Now, of course, to be able to see the effects of our code, the macro has to be enabled in the victim's Office tool. Now, I'm using Office 2013. To enable macros, I follow the path file, options, trust center settings. And click Enable all macros, then the OK button. Save the Word document on the desktop and close. Now the document has the macro code inside, and the macros are enabled in the Office tool. Now I want to touch on two topics here. First, as you can see in the right-hand corner of the screen, I'm going to open the malicious document while Windows Defender is running. So we'll see if we can bypass the security systems or not. Second, of course, we don't expect the victim to prepare the file himself. We are testing the document that we prepared. Sending it to victims and convincing them to open the files is another case. Now open the Word document. Seems everything's fine. Something abnormal doesn't appear. Let's go to our Kali system. As you see, we have a new agent initialized. Go to the main menu using main command. There was one agent at the beginning. Now we have two of them. Go to agent state using agent's command. The second one is our new session, which started when the victim opened the Word document. Use interact command with the agent name to activate the session. Now, the victim machine is in your hands. There are tons of applications that require Java to work. This is why Java runtime environment is installed on almost every computer. According to Oracle, 97% of enterprise desktops run Java. 89% of desktops or computers in the USA run Java. 3 billion mobile phones run Java. 100% of Blu-ray disc players ship with Java. And 125 million TV devices run Java. In the 2010s, there were several numbers of exploitable Java vulnerabilities found. Most of them were allowing the attackers to execute remote codes in the victim's systems. Because almost every IT system has Java, and several critical zero-day vulnerabilities have been found in the recent years, exploiting Java vulnerabilities on the client side is quite popular. When you search for Java in Metasploit framework, you find a lot of exploit written for Java vulnerabilities. Some of them are seen in the slide. Let's see one of them in detail. The exploit module displayed in the slide abuses the JMX classes from a Java applet to run arbitrary Java code. Additionally, this module bypasses default security settings introduced in Java 7 Update 10 to run unsigned applets without displaying any warning to the user. To use the exploit, run use command with the full exploit name. Set the options of the exploit and run it using exploit or run command. Same as the Firefox add-on exploit, it starts to serve an application on the server SRV host at the port SRV port with a path given in the URI path option. At the same time, it starts a reverse TCP handler to collect the captured session on the same system with SRV host at the port 4444. Did you notice that we didn't set a payload for the exploit? By default, the exploit uses Java/meterpreter/reverse_TCP payload. Social Engineering Toolkit, SET. The Social Engineering Toolkit, SET, was created by Trusted SEC. It is an open-source Python-driven specifically designed tool to perform advanced attacks against the human element. It's a standard tool in a penetration tester's arsenal. The attacks built into the toolkit are designed to be targeted and focused attacks against a person or organization used during a pen test or ethical hacking. You can download SET from Trusted SEC's GitHub and use any platform you want, and it's already embedded in Kali and ready to use. The tree on the slide shows the attack types under the social engineering attacks branch of the main menu SET. And the green layer shows the methods of website attack vector options. I mean, there are many more methods and attack vectors in the toolkit. Let's see one of the attack methods of the social engineering toolkit, Credential Harvester Attack. In this attack, first we should choose a website which has a login sequence that the victims often visit. The toolkit prepares the clone of that website and serves it at the server. Our trap is ready and starts to collect the inputs of the victims. When a victim visits our website, he or she will face exactly the same page that he or she visits often. The victim enters the credentials and we collect them. Let's do it together. Social Engineering Toolkit is installed and ready to use in Kali. It's defined in the path so you can start the toolkit anywhere using set toolkit command. Choose Social Engineering Attacks option in the main menu, that's number 1. As the attacked vector, select Website Attack Vectors, that's number 2. And our attack method is the Credentialed Harvester, number 3. This menu is the list of the phishing website creation methods. Let's choose Site Cloner, number 2. We need to have a website where the victims visit and log in often. I want to find a login page for the NHS. Googling for NHS and login keywords, email.nhs.net seems good. Post-back IP address is used for what IP the server will post to. Now this is the URL to clone. I use email.nhs.net. The version of the toolkit I use is 7.6.1, and when I want to clone a website, I get a zip importer error and the method does not continue. When I Google the error message, I found a solution for this problem in the issues section of the GitHub page on the Social Engineering Toolkit. Go to /etc/ctoolkit/set.config file. In line 95, turn off to on. And save the file before closing. Now run the SE toolkit again. Follow the menus again, 1, 2, 3, 2. Enter the IP address of our Kali machine as post-back IP address. Enter email.nhs.net as the URL to clone. The same error message is here again, but now the program continues and asks for starting Apache's server if it's not running at the moment. Answer Y for yes, and the trap is ready. The site's cloned, Apache's server is started, and the credential harvester is listening to the inputs now. As the victim, when we visit the malicious website, we will see exactly the same page with email.nhs.net. Enter the username and password, click Sign In. Our malicious website redirected the victim to the original page, email.nhs.net. It's a good idea. The victim will not be in any doubt about the fraud. Turn back to the attacker system, Kali, and you'll see the credentialed information entered by the victim. You can leave this command window. Everything is still running and logging under your web directory path /var/www/html. To make the credential harvester attack more realistic, you can use some tricks. For example, you can use the domain name of the target company as a subdomain name of your registered domain name. Suppose that you're the owners of xyz.com domain, and the domain name of the target company is thecompany.com. You can prepare a URL like thecompany.xyz.com. Another way to make the attack more realistic is to buy a domain name similar to the domain of the company. For example, if the target domain is thecompany.com, you can try to buy the company with a double N. You can also use the URL Crazy tool to find out the alternative website names. If you're an insider, you can try to match the domain name with your IP address to redirect the victims to your servers using DNS spoofing. Sending fake emails. The more realistic the phishing email we send, the more likely the attack will be successful. For this reason, it's better to make the email look like it's coming from the real source. For example, if you're acting as a job finder site, make the phishing email seem as if it's sent by one of the legitimate job sites. There are several fake email services. MKai's Mailer is one of the free online fake mailer services, which has its own reverse DNS record. If you send an email with MKai's Mailer, it will probably be flagged as spam because MKai's Mailer is a well-known service. Even though the mail is flagged as spam, it still looks like it's being sent by the legitimate job site. The victim has to investigate the headers of the email to understand if it's really sent by the job site or not. If you look at the headers, you'll see that the email is sent by mkai.cz, not by jobsite.co.uk. So if you've got a suspicious email, don't forget to investigate the headers before opening it. Social engineering attacks by phone is also called vishing, where the word is a combination of voice and phishing. Vishing attacks are highly effective if you've done your homework and have all the relevant information, and you already know where you get the information in the first place. This is where the information gathering phase comes into play. You need to have a realistic scenario first. Before you call the victim, you have to be very well prepared. Who are you? Where are you calling from? What's your expertise? What's the subject? What do you want from the victim? The more you prepare, the more the victim will trust you. There are some tricks to being more realistic. For example, if you're in the role of a call center staff, it's better to have a background voice as if some other staff are talking with other customers or clients. It's a very effective way to frighten the victim. Your computer is blocking $1 million transaction to the company. We have to fix it immediately. Have you recently visited websites that you should not have visited? Here then is the real-world social engineering test that we performed in one of our pen tests. According to the scenario, we are an IT department staff and want to make sure if all the employees got the critical security update of the corporate email service. The critical points of the attack are as follows. First, introduce yourself as one of the personnel from the IT department. Now, at information gathering and reconnaissance phase, if you found the real names working in the IT department, use one of these names. But prepare yourself. The victim may know the person whose name you're using. If you don't know anyone in the IT department, choose a common name. What's the most common name in that country? Second, make the victim nervous about his or her mistake. The words critical and security are important. You should have got the update up to now, but you haven't? Third, gain the trust of the victim. Don't share any information with me or anyone else. Security is important. Give the IP address of your malicious website. Because you share the URL on the phone, don't try to find a URL similar to the company's webmail service. IP is good, but it's not understandable. Since the victim manages the steps him or herself, he or she has no doubt that the operation is secure. The victim visits our website, which looks like the webmail service of the company, and downloads our backdoor as the security patch. The success rate of this test was 90%. In this course, you learned the terminologies and definitions of social engineering, basic social engineering techniques, social engineering types and the steps of the social engineering tests, how to bypass security measures, how to create malware, how to create custom payloads to use inside the malware, how to embed the malicious code into the documents, the social engineering toolkit, and social engineering via phone, also known as vishing.
Now, we do have some prerequisites for conducting Wi-Fi security tests, like having some hardware. But don't worry, these aren't expensive tools. It'll be enough to have a PC and a Wi-Fi USB adapter to complete this training. Now, the most important thing to watch out for when buying a USB Wi-Fi adapter is that it has monitor mode and allows you to inject packets. Now, based on our experience, we can say that the chipset of most of the Wi-Fi USB adapters sold on the market do not have these features. You can use one of the Wi-Fi adapters listed in the table during the tests. So in fact, we use the TP-Link TLWN722N high-gain wireless USB adapter as our hardware throughout the course. The TP-Link high-gain wireless USB adapter allows you to connect a computer to a wireless network and access a high-speed internet connection. It provides wireless speeds of up to 150 megabits per second. It is compliant with IEEE 802.11n and gives you a more robust wireless signal than existing wireless 802.11g technology can provide. It has the ability to reduce data loss over long distances and through obstacles in a small office or large apartment. And it automatically avoids channel conflicts using its clear channel assessment technology, and this is greatly enhancing our wireless performance. It also supports WPA, WPA2, as well as WEP encryptions to protect the wireless network efficiently. So to get better signal performance, the adapter's 4 dBi high-gain external antenna can be rotated and adjusted in different directions to fit various environments. The adapter has a quick security setup that allows you to almost instantly set up your security. Just by pressing the QSS button, it'll establish a WPA2 secure connection. So I'll use the TP-Link Wi-Fi adapter in this course, but of course there are other hardware and wireless auditing platforms for Wi-Fi pen testing that you can use for the course, like Pineapple and Fruity Wi-Fi. The Wi-Fi Pineapple is a piece of hardware that was originally created for network penetration testing. Wi-Fi Pineapple allows pen testers to perform targeted man-in-the-middle attacks, advanced discovery, credential gathering, open source intelligence gathering, and more with a web interface. Now, Fruity Wi-Fi is an open-source tool to audit wireless networks. It allows the user to deploy advanced attacks by directly using the web interface or by sending messages to it. Initially, the application was created to be used with Raspberry Pi, but it can also be installed on any Debian-based system. Now, I am true to my word when I say that I'll be using lots of tools for attacking Wi-Fi networks. You might be familiar with some of these as they are the most often used. Some of them are the more advanced tools for Wi-Fi pen testing. So what we like to do is use a bunch of different tools, in fact, using as many different tools as possible for different attack scenarios, thereby introducing you to how to use each one of them, including the ones that you know, and hopefully introduce you to a whole bunch more that you haven't even heard of before. We'll explain all this in detail shortly, but I just want to let you know that we will be installing the tools before using them in the upcoming lectures. So we're not going to install all of them when we set up our laboratory. So here we're going to use KRACK NG. And KRACK NG consists of a detector, a packet sniffer, WEP, and WPA, WPA2-PSK crack and analysis. It includes Airmon NG, Airplay NG, Aerodump NG, Airbase NG, and PacketForge NG. Sounds like fun, huh? Yes, we're going to be using all these tools. Wi-Fi TE. Now, Wi-Fi TE runs existing wireless auditing tools. Wi-Fi TE is designed to use all known methods such as WPS pin attack, WPA handshake capture, as well as web attacks. Bettercap. Now, Bettercap is a powerful, flexible, and portable tool created to perform various types of man-in-the-middle attacks against a network, manipulate HTTP, HTTPS, and TCP traffic in real time, sniff for credentials, and so much more. Fluxion. So Fluxion is a security auditing and social engineering research tool. It attempts to retrieve the WPA-WPA2 key from a target access point by means of a social engineering attack. You might know that as phishing. Hashcat. So Hashcat is a type of hacking tool, and it's a password cracker specifically. It was created to be able to hack the most complex passwords, targeting multiple aspects of coding simultaneously. But what we're going to be using Hashcat for is for cracking WPA2 by using GPU in this course. Here's a favorite, Wi-Fi Pumpkin. Now, the Wi-Fi Pumpkin is a rogue access point framework. It'll easily create fake networks, all while forwarding legitimate traffic to and from the unsuspecting target. We're going to use something called Kismet. Kismet is a wireless network and device detector. It's a sniffer, and it's a war driving tool. And Cowpatty. So Cowpatty is a C-based tool for running a brute force dictionary attack against WPA keys. Now, hopefully you're as excited as I am because this is some very rich content, yeah? So why don't we just get started? We'll set up the laboratory next. All right, so before we start, we'll plug in the Wi-Fi adapter to Kali and check the connectivity. So first we'll start the Kali machine. Log in with default credentials, Kali and Kali. Now plug in the Wi-Fi adapter to the host machine. So let's look at the devices on the top left menu. And there are Wi-Fi adapters and my USB converter on the list. So click the name of the Wi-Fi adapter to connect the virtual machine. And now let's double check on the terminal screen with the LUSB command. And sure, the adapter is there, but the adapter's light is still not on. I don't know if you noticed that. So I will run the iwconfig command. Now it's similar to ifconfig, but it is dedicated to wireless interfaces. So it's used to display and set the parameters of the wireless network interface. But you see that there is no wireless network interface here. So in order for VirtualBox to recognize our USB devices, that means that we've got to add the user to the VirtualBox users group. So why don't we go ahead and list the groups that my user belongs to. Groups $user, and there is no VirtualBox user group here. Sudo user mode -a-g vbox users Kali. And if there is no group named VirtualBox users, why don't we create it? Sudo add group vbox users. So now we can add the user to this group. Okay, so now let's go back and look at the groups again. All right, you see how that works? Now we've got to reboot the machine, but I'll shut down just to adjust the USB settings. So let's go to the settings of Kali, click Ports and USB. Now naturally there's a more permanent solution that captures the device as soon as it's inserted into the host. So while the Wi-Fi adapter is plugged in, we can create USB device filters for each device. So I'll create new filters for my Wi-Fi adapter and MacBook USB connector device. Click OK. Now unplug the Wi-Fi adapter and start up Kali again. Log in with default credentials. Now, plug in the Wi-Fi adapter again. Let's have a look at the devices. And yeah, the devices are still there. But I will also check with LSUSB and IWconfig again. But there is no light. Well, I guess VirtualBox does not recognize the adapter because my MacBook USB converter device supports USB 3.0. So I'll change the USB controller and make it 3.0. Okay, so finally the light is on and VirtualBox recognizes the wireless interface. So if you're using a USB converter device, remember to change the USB controller for your particular device. Now if you're using VMware, these steps are pretty easy. First, start the Kali machine. Log in with the default credentials, Kali and Kali. Now plug in the Wi-Fi adapter to the host machine. VMware asks for your choice to connect the adapter. Select Connect to Linux. Then open the terminal screen. First, we'll switch the user to root with sudo su-. Do not write sudo for every command that requires root privileges, right? All right, so let's run lsusb, and that'll display the information about the USB buses as well as the devices connected to Kali. And sure enough, here is our Wi-Fi adapter. So now let's run the IWconfig command. WLAN 0 is the name of the first wireless network interface on the system, and it displays the details of our Wi-Fi adapter. Great, so we see detailed information about the concepts here in the next lecture, so don't worry about it now. But we will look at the connected USB devices in VMware settings. So let's go to the toolbar. Click the settings icon and select USB and Bluetooth. And here you'll find a list of connected USB devices. And you can also see them here to make sure your device is connected. IEEE 802.11. So the IEEE is an acronym for Institute of Electrical and Electronics Engineers. It was formed way back in 1963. Now they're a group of scientists, engineers, and allied professionals who together are the leading authority in aerospace, telecommunications, biomedical engineering, electrical power, etc., etc. The IEEE is separated, however, into various committees. So the 802 committee develops local area network, or LAN standards, as well as Metropolitan Area Network Standards, or MAN standards. The IEEE 802.11 is a set of wireless LAN standards developed by the IEEE Working Group 11 in 1997. The 802.11 family consists of a series of standards and amendments, but I'll explain the main and the widely accepted ones. So first we have the original IEEE 802.11 standard released in 1997, and it defined the rates of 1 or 2 megabits per second on 2.4 gigahertz band. Then 802.11b standards were created in 1999. It'll provide 5.5 and 11 megabits per second rates on the 2.4 gigahertz band. Now, come on, they're only just getting started. The IEEE 802.11a, that was released around the same time as 802.11b. 802.11a uses the 5 gigahertz band. Now, the 5 gigahertz band has way more channels that are available, and they do not overlap like those in the 2.4 gigahertz band. So then, moving through 2003, IEEE 802.11g was introduced and extended throughput to up to 54 megabits per second using the same bandwidth as 802.11b. And it just so happens it's backward compatible with IEEE 802.11b. Now, IEEE 802.11i is an amendment to the original IEEE 802.11. It implemented Wi-Fi Protected Access 2, or WPA2, released in 2004. So the standard specifies security mechanisms for wireless networks. Then they were able to deprecate the wired equivalent privacy, or WEP, because it had security vulnerabilities. So then in 2004, work began on IEEE 802.11n, and that increased transfer speeds and provided more range on 2.4 gigahertz and 5 gigahertz networks. So that brings us to 2009, when the final release of 802.11n was completed. So IEEE 802.11n is an amendment, and it builds on previous 802.11 standards by adding multiple input, multiple output, or MIMO, right? MIMO is a form of antenna technology that uses multiple antennas to enable signals traveling via different paths as a result of reflections and all the other types of interference. They can be now separated, and their capability is used to improve the data throughput and or the signal-to-noise ratio, thereby improving system performance. Now, some of the basic terminologies, these are going to be very important for us to understand the following lectures, so I just want to make sure that we're on a basically same page, right? Because you're going to hear these concepts in any resource about Wi-Fi networking, and of course, throughout this course. Now, if you already know the basic terminology, sure, you can go ahead and skip to the next lecture. So an access point, an AP. This is a device that serves as a central wireless connection point for a Wi-Fi network. The Service Set Identifier, or SSID. It's the name of the wireless network. It can be contained in the beacons sent out by access points, or it can be hidden. So the clients who wish to associate must first know the name of the network first, right? So early security guidance was to hide the SSID of your network, but modern networking tools can detect the SSID simply by watching for legitimate client association, because SSIDs are transmitted in clear text. BSSID, Basic Service Set Identifier. It's a unique address that identifies the access point or hub that creates the wireless network. The Extended Service Set Identifier, or ESSID, it's the name of the wireless network and is used by all APs that provide access to the same infrastructure in an extended service set. It can be advertised by APs and their beacons, or suppressed so that clients must know the ESSID before associating with an AP. Roaming. So in a wireless network with multiple APs, a client that is moving from the coverage area provided by one AP to that provided by another is called roaming. So it must disassociate from the first AP before it can associate to the next AP. A channel. This is the network path for wireless transmissions. Each Wi-Fi standard has numerous channels, each of which is a specific central frequency. Data rate. The rate in which data can be transferred at any given moment to and from a device. Most times, the incoming and outgoing data transfer rates affect each other adversely. For example, if you're uploading a video while loading a web page, the web page will load slower than usual due to the upload usage. A beacon is transmitted by an AP 10 times per second, and it advertises the existence of the AP on a particular channel or channels. It includes information needed by clients to associate, as well as it may include the ESSID, the supported channels, as well as data rates, and whether it's open or requires authentication. Now, decibels can also be used to describe antenna power levels. A decibel is the basic unit of measurement used in Wi-Fi radio signals. dB specifies the difference or ratio between the two signal levels, and is used to describe the effect of system devices on signal strength. So a dBm is the dB value compared to 1 milliwatt of power. For example, if the signal power is 100 milliwatts and the reference is 1 milliwatt, the value of the decibel becomes 20 relative to a milliwatt. Make sense? So our TP-Link adapter's antenna has 4 dBi signal power. Now a suffix indicates that the reference value is often appended to the decibel symbol. The suffix is I because I refers to an isotropic antenna, which is equally sensitive to signals from all directions. The gain is a key performance number, and this combines the antenna's directivity and electrical efficiency. So in a transmitting antenna, the gain describes how well the antenna converts input power into radio waves headed in a specific direction. There are 2 main wireless operating modes: infrastructure and ad hoc. So in the case of wireless networking in infrastructure mode, you are connecting your devices using a central device, namely a wireless access point. To join the WLAN or wireless LAN, the AP and all the wireless clients are configured to use the same SSID. The AP is then cabled to the wired network to allow wireless clients to access, for example, internet connections or printers. Additional APs can be added to the wireless LAN to increase the reach of the infrastructure and support any number of wireless clients. So compare or contrast this to ad hoc mode networks. Now this makes wireless connections directly between computers. Infrastructure mode wireless networks use networking infrastructure. So in this case, infrastructure refers to switches and routers, firewalls, access points, or APs. Infrastructure mode wireless networking is the mode that you'll most often encounter in your work as a networking professional, supporting networks for clients or in a corporate or enterprise environment. At a minimum, the only network infrastructure component that is required for infrastructure mode is an access point. But if an AP is all you have no more than you would have when you're using ad hoc mode. However, most infrastructure mode applications and implementations include other components from, just traditional network infrastructures. On Linux-type operating systems, acting as a station, namely a client, is usually called managed mode, and when acting as an AP, it's usually referred to as master mode. An ad hoc network consists of at least 2 stations communicating without an AP. This mode is also called peer-to-peer mode. In an ad hoc network, one of the participating stations takes on some of the responsibilities of an AP, such as beaconing and the authentication of new clients joining the network. So in ad hoc mode, the station taking on the responsibilities of the AP does not relay packets to other nodes like an AP does. Monitor mode is not really a wireless mode, but it is essentially important in attacking wireless networks. In a nutshell, monitor mode allows a wireless card to monitor the packets that are received without any filtering. So monitor mode is essentially the promiscuous mode, if you will, equivalent for wireless. In both cases, actually, you see all the packets going across the wire or channel. Now, when using some wireless drivers, this mode allows for the sending of raw 802.11 frames. This mode is important for reading packets from the card, analyzing them, and updating the user interface as it determines new information. It doesn't transmit packets themselves. Instead, it listens to all the packets on a given channel and then analyzes those packets to see just what's going on. So if you and your neighbor share the same channel, When you put your card into monitor mode to see what's going on in your network, you're going to see their traffic as well. So why don't we go ahead and see how to enable monitor mode of the wireless network card in Kali Linux. So we'll go to the Kali machine and plug in the Wi-Fi adapter. That goes into your host machine. Open the terminal screen and switch the user to the super user. So you got to do that first. Now let's see the status of the adapter with the iwconfig command. So its mode is managed right now. So we can enable monitor mode with the script airmon-ng. So if we run this command without any parameters, it lists the status of the wireless interfaces. To enable monitor mode, run airmon-ng start wlan 0. And as you can see, before enabling it, we must kill the processes of the network managers with the airmon-ng check kill command. So now let's try to run the previous command again. And it doesn't work now because we killed the processes of the network interfaces. And then wlan 0 is switched to monitor mode. All right, so let's have a look at the status again. And there it is on monitor mode. So I'll quickly provide a short explanation of each. All right, so MAC frames consist of three main structures. The frame body is a variable length field. It contains information specific to individual frame types. FCS stands for frame check sequence. All right, so it's an error detecting code that's added to each frame. And in the MAC header, there's a frame control section. All right, so if you're uploading a video while loading a web page, the web page will load slower than usual due to the upload usage. A beacon is transmitted by an AP 10 times per second, and it advertises the existence of the AP on a particular channel or channels. It includes information needed by clients to associate, as well as it may include the ESSID, the supported channels, as well as data rates, and whether it's open or requires authentication. Now, decibels can also be used to describe antenna power levels. A decibel is the basic unit of measurement used in Wi-Fi radio signals. dB specifies a difference or ratio between the two signal levels and is used to describe the effect of system devices on signal strength. So a dBm is the dB value compared to 1 milliwatt of power. For example, if the signal power is 100 milliwatts and the reference is 1 milliwatt, the value of the decibel becomes 20 relative to a milliwatt. Make sense? So our TP-Link adapter's antenna has 4 dBi signal power. Now a suffix indicates that the reference value is often appended to the decibel symbol. The suffix is I because I refers to an isotropic antenna, which is equally sensitive to signals from all directions. The gain is a key performance number, and this combines the antenna's directivity and electrical efficiency. So in a transmitting antenna, the gain describes how well the antenna converts input power into radio waves headed in a specific direction. There are two main wireless operating modes: infrastructure and ad hoc. So in the case of wireless networking in infrastructure mode, you are connecting your devices using a central device, namely a wireless access point. To join the WLAN or wireless LAN, The AP and all the wireless clients are configured to use the same SSID. The AP is then cabled to the wired network to allow wireless clients to access, for example, internet connections or printers. Additional APs can be added to the wireless LAN to increase the reach of the infrastructure and support any number of wireless clients. So compare or contrast this to ad hoc mode networks. Now this makes wireless connections directly between computers. Infrastructure mode wireless networks use networking infrastructure. So in this case, infrastructure refers to switches and routers, firewalls, access points, or APs. Infrastructure mode wireless networking is the mode that you'll most often encounter in your work as a networking professional, supporting networks for clients or in a corporate or enterprise environment. At a minimum, the only network infrastructure component that is required for infrastructure mode is an access point. But if an AP is all you have no more than you would have when you're using ad hoc mode. However, most infrastructure mode applications and implementations include other components from, just traditional network infrastructures. On Linux-type operating systems, acting as a station, namely a client, is usually called managed mode, and when acting as an AP, it's usually referred to as master mode. An ad hoc network consists of at least two stations communicating without an AP. This mode is also called peer-to-peer mode. In an ad hoc network, one of the participating stations takes on some of the responsibilities of an AP, such as beaconing and the authentication of new clients joining the network. So in ad hoc mode, the station taking on the responsibilities of the AP does not relay packets to other nodes like an AP does. Monitor mode is not really a wireless mode, but it is essentially important in attacking wireless networks. In a nutshell, monitor mode allows a wireless card to monitor the packets that are received without any filtering. So monitor mode is essentially the promiscuous mode, if you will, equivalent for wireless. In both cases, actually, you see all the packets going across the wire or channel. Now, when using some wireless drivers, this mode allows for the sending of raw 802.11 frames. This mode is important for reading packets from the card, analyzing them, and updating the user interface as it determines new information. It doesn't transmit packets themselves. Instead, it listens to all the packets on a given channel and then analyzes those packets to see just what's going on. So if you and your neighbor share the same channel, when you put your card into monitor mode to see what's going on in your network, you're going to see their traffic as well. So why don't we go ahead and see how to enable monitor mode of the wireless network card in Kali Linux. So we'll go to the Kali machine and plug in the Wi-Fi adapter. That goes into your host machine. Open the terminal screen and switch the user to the super user. So you got to do that first. Now let's see the status of the adapter with the iwconfig command. So its mode is managed right now. So we can enable monitor mode with the script airmon-ng. So if we run this command without any parameters, it lists the status of the wireless interfaces. To enable monitor mode, run airmon-ng start WLAN 0. And as you can see, before enabling it, we must kill the processes of the network managers with the airmon-ng check kill command. So now let's try to run the previous command again. And it doesn't work now because we killed the processes of the network interfaces. And then WLAN 0 is switched to monitor mode. All right, so let's have a look at the status again. And there it is on monitor mode now. And the name WLAN 0 became WLAN 0 mon. So to disable monitor mode, just run airmon-ng stop WLAN 0 mon. And now it's changed back again. So after these steps, please note that we must restart the network manager. So service, network manager start. And then finally, let's check to double ensure that the network manager is up and running. And sure enough, everything looks okay. Very cool. All right, so let's begin our journey by looking at the structure of an 802.11 MAC frame. So a MAC frame is constructed of common fields and specific fields. So I'll quickly provide a short explanation of each. All right, so MAC frames consist of three main structures. The frame body is a variable length field. It contains information specific to individual frame types. FCS stands for frame check sequence. All right, so it's an error detecting code that's added to each frame. And in the MAC header, there's a frame control section. All right, so the very first two octets transmitted by a station are the frame control. Protocol version. Now this will provide the version of the 802.11 protocol used, and the value is currently 0. We also have type and subtype. These will tell you what the function of the frame actually is. So there are three different frame types of fields: control, data, management. There are multiple subtype fields for each frame type, and then each subtype determines the specific function to perform for its associated frame type. So to move on, to DS and from DS indicates whether the frame is going into or exiting the distribution system. Right? More frag indicates whether more fragments of the frame are to follow this one or not. Retry indicates that the frame is being retransmitted. Power management indicates whether the sending STA is in active mode or power save mode. WEP indicates whether or not the encryption and authentication are used in the frame. Order indicates that the frame is being sent using the strictly ordered service class. Right? Now the field is usually not set. Duration ID indicates the time on the channel that the sender is assuming to be occupied from the end of the current frame. Now here are some different cases of the fields of addresses depending on the communication between the station and the access point. Sequence control is used to recognize frame duplication by setting the sequence number of each frame. Okay, so now we get into data packets. So data packets are used in order to carry higher level data, such as IP packets. So the 802.11 standard divides all packets into three different categories: control, management, and data. So these different categories are known as a packet type. So wireless control frames are short messages that tell devices when to start or stop transmitting and whether a connection failure has occurred. An ACK frame, or an ACK frame, is used to tell the sending station that the receiving node received the packet correctly. So these packets are sent relatively quickly for each unicast packet sent. Most of the time, to speed up the sending of ACKs, it's done by the hardware itself and not the driver. Wireless adapters can be placed in power saving mode, basically to increase battery life. So when a station is in power saving mode, the AP buffers the traffic destined for it. The AP uses a traffic information message to inform the station that it has some data waiting for it and then transmits it in beacon frames. RTS-CTS is a mechanism that helps in reducing collisions. So it adds overhead to wireless communication, as additional packets have to be added to the beginning of the communication. For example, we'll assume that there are two nodes who want to communicate with each other. So let's say that node 1 sends a request to send to node 2. Now, if there's no collision and the request is accepted, node 2 sends a clear to send to node 1, telling it to proceed. So node 1 will send its data. And then finally, node 2 sends ACK if the data was received. Nothing is sent if it fails. Management frames are also used to negotiate and control the relationship between access points and stations. Now, the following table here will outline the different types of wireless management frames. Beacon frames are the most common packets, as they're sent at a rate of approximately 10 times a second. Beacons are broadcast by the AP to keep the network synchronized. So the beacons contain useful information about the network, such as network name and the capabilities of the AP, the data rates available, and all that. Now, probe frames are used to scan for existing access points, and they consist of two different packets: probe request and probe response. So probe requests are sent by wireless stations to determine what APs are within range and what their capabilities are. A probe response is sent only if the speed and ESSID values are the same as those supported by the node. The node that responds to the request is the last node that sends a flag. Now, within an authentication frame, the authentication algorithm will identify the type of authentication used. So a value of 0 is used to indicate open system authentication, and a value of 1 is used for shared key authentication. So once a station successfully authenticates to an AP, it needs to perform an association before fully joining the network. Association and reassociation packets are used to perform these steps. Now, when all communications are terminated, the station or AP can send a deauthentication packet. Now, there are many different reasons for this frame. For example, clients may no longer be authorized, or a client session timeouts may exceed. We'll see some of those details and the importance of this frame when we cover the deauthentication attack in an upcoming lecture. Now, ATIM frames. They're only used in ad hoc networks. A station uses this frame to notify the recipient that it has buffered data to send. So IEEE 802.11h adds support for action frames that trigger specific measurements. These frames are not very common, and therefore we're not going to really talk about them in detail. But you should know that they exist. Okay. So the last packet type is data frame. And the purpose of a data frame is to transfer data from an upper layer of a station to another wireless or wired station on the network. Null frames will consist of only MAC headers and an FCS. And they're used by stations to indicate that they are going into power-saving mode. All right, makes sense. So let's have a look at some of the packets in detail, and we'll analyze them with Wireshark. So for this, I want you to open up the terminal screen. And we'll first check the mode of the Wi-Fi adapter, and sure enough, it is on monitor mode. Now let's run Wireshark with root privileges. Now before capturing any traffic, we need to select a network interface on this list. So let's select WLAN 0MON and click on the capture button. All right, so now Wireshark is listening to network traffic. As you can see, there are lots of beacon frames, probe requests, and probe responses between the different sources and destinations. So we'll stop the capturing, and we'll look at the details of the packets. So in this section, there's time, source, destination, protocol length, and detailed information about the packet. In the middle of the screen here, there's detailed information for a specific packet. Details about frame and header. As you can see, this is a probe response packet. The frame control field contains the destination address, as well as the transmitter address of this packet. And we can see the SSID in the wireless management field. We can customize the appearance of the results in the preferences under the Edit tab. And you can add a new field if you want to, and that will display in the columns. So here you can select the type of field, and I want to add frequency and channel information. And there's the column that we added. Now this is one of the most important and widely used features of Wireshark. We can filter the scan results. Otherwise, it's really kind of difficult to find the package that we want to view easily. For example, when we want to list the packets related to a specific access point, we can use this filter just by giving the SSID name of the access point. Click on this button. Now, all the packets that belong to this access point, called Hacker Academy, are here. In addition, we can also filter by selecting any parameters. So select any information there, right-click on it, and now you can click Apply as Filter and select. All right, so I filtered the management packets. Now let's display only beacon frames. If you want to, you can select two filters, and you can always do this with the AND selected option. As you can see, it's added to this line with the AND parameter. All right, so now I'm listing beacon frames sending broadcast signals. I'll add another filter to display packets related to Hacker Academy. So Wireshark has many different filters. According to the result that you want to see, you can find the most suitable filter, even on the internet. I'd also like to show you some of the control management and data packets that I mentioned in the previous lecture. For example, we can see the request to send packets using subtype number 27. RTS and CTS are controlled packets, and they're the optional mechanisms to reduce frame collisions. The subtype number of CTS packets, 28. So let's change the filter with this number, and there's only one CTS packet here. Cool, so let's have a look at the other types of packets now. You might not be able to see all packet types in your scan results. So to analyze packet types, let's download the sample captures just right from the internet. Just type Wireshark sample captures and click on Wireshark's website. And there are lots of different examples of sample captures on this list. So for now, let's find the Wi-Fi captures and select one of the capture files here. All right, so go to Wireshark and we'll close this scan. Open up the downloaded capture file. All right, so let's have a look at the packets in this file. And there are some authentication packets here, and these are the details of this packet. And as you see, the subtype number is 11, so we can use this filter to see only the authentication packet. You can also see the details about the packets by double-clicking on it. So finally, let's have a look at the data packet with subtype 32. Now look, in the middle part, we can see the transmitted data in encrypted form in the data section. All right, so let's illustrate the steps that take place when a client connects to an access point, and then we can visualize how the data transmission works. So STA means a station, a client that wants to connect to an access point. AP represents that access point. Now we can separate this process into three main parts, right? Probe, authentication, and association. So in the probe process, the STA first sends a probe on all channels to find the AP. And then the APs in range answer the probe request. And of course, this is the very first step of connection. So in this phase, the driver of the client searches for an AP. Then, in the authentication process, the STA sends an authentication request to the AP, by default to the one with the best signal. And And then it also checks the compatibility of the encryption type. And then once compatible networks are discovered, the station will attempt authentication with compatible access points. And then the access point will receive the authentication frame, and then it responds to the station with the authentication frame set to open, indicating a sequence. If an access point receives any frame other than an authentication or a probe request from a station that is not authenticated, it will respond with a deauthentication frame. And then finally, in the association process, once the station determines which access point it would be most likely to associate with, it will then send an association request to that access point. And then if the elements of the association request match the capabilities of the access point, it will create an association ID for the station, and then respond with an association response with a success message, granting network access to that mobile station. Now, the STA, or station, can communicate with the network. So after all of this process is finally completed, data can then be exchanged on the network. Now, please note that there is an other phase for encrypted networks. There's a key exchange and verification that will happen just after association before you're able to use the network. All right, so now let's have a look at the authentication methods. Now, there are two types of authentication. The shared authentication, and it's only used with web and open authentication. So the steps that take place during an open authentication are basically the wireless client sends an authentication request to the access point. The access point then sends an authentication response, and the authentication process is completed successfully. Shared key authentication is another method of authenticating with web-enabled networks. So the station sends an authentication request to the access point. The access point sends a challenge text to the station. The station then uses its default key to encrypt the challenge text and sends it back to the AP. The AP then decrypts the encrypted text with the web key that corresponds to the station default key, and then compares the result with the original challenge text. If there's a match, of course, that means they share the same key, and the AP authenticates the station. If there's no match, the AP refuses to authenticate the station. So let's have a look at the association process in Wireshark. So I captured the packets of association processes that took place between a phone and my access point. So first I filtered the result by applying the MAC address of the phone as the source address. Then the process takes place here, so probe request, authentication, and association packets, respectively. Then when we add a filter by applying the access point as the destination, we can see the response packets sent by the access point for the association process. So the wireless security protocols are WEP, WPA, and WPA2. Now, of course, they probably on some level serve the same purpose, but they're certainly different all at the same time. So not only do wireless security protocols prevent unwanted parties from connecting to your wireless network, but also encrypt your private data sent over the airwaves. So wired equivalent privacy, or WEP, that is the 802.11 standard that was introduced to provide privacy features similar to those found in wired networks. Then as soon as flaws in WEP were discovered, IEEE created a new group called 802.11i aimed at improving Wi-Fi security. And then WPA, or Wi-Fi Protected Access, replaced WEP in 2003. Then followed swiftly on the heels by WPA2, or another 802.11i standard, in 2004. So WEP was designed to provide the same level of security as that of a wired LAN. Now, because wireless networks broadcast messages using radio signals, they are susceptible to eavesdropping. WEP provides security by encrypting data over radio waves so that it's protected as it's transmitted from one endpoint to another. WEP uses the stream cipher RC4 for confidentiality, CRC32 checksum for integrity. So now there are two methods of authentication that can be used with WEP: open system authentication and shared key authentication, which I briefly mentioned earlier. If privacy is of primary concern, it's more advisable to use open system authentication for WEP authentication, rather than shared key authentication. However, it also means that any wireless LAN client can connect to the AP. So basically, both authentication mechanisms are kind of weak, right? Shared key WEP is deprecated in favor of WPA and WPA2. So then the recommended solution to WEP security problems? Switch to WPA2. WPA was an intermediate solution for hardware that couldn't really support WPA2, yet we still talk about it. But WPA uses a message integrity check algorithm. It's called TKIP, and it verifies the integrity of the packets. It prevents an attacker from altering and then resending data packets. WEP used an unchanged 64 or 128-bit encryption key that must be manually entered into wireless access points and devices. TKIP uses one key per packet, which dynamically creates a new 128-bit key for each packet. I mean, that's insane, right? But definitely prevents WEP attacks. So, after a security flaw appeared in WPA, WPA2 with a stronger encryption algorithm was released to replace WPA. So that's why we still talk about WPA, but really we're talking about WPA2. Now you get it. So WPA2, it's also called robust security. It is a secure network, which is a type of association used by pair stations to establish authentication or association between them, and it includes the four-way handshake. Now, if you're not familiar with it, we'll briefly discuss the four-way handshake because it's the process of exchanging four messages between an access point and the client, and that'll generate some encryption keys which can be used to encrypt the actual data sent over wireless signals. The initial authentication process is carried out either by using a pre-shared key, a PSK, or an extensible authentication protocol, or EAPOL, that provides an authentication mechanism to devices wishing to attach to a LAN or a WLAN. So after the PSK authentication, a shared secret key is generated called the pairwise master key, PMK. So once the client has the PMK, it and the AP negotiate a new temporary key called the pairwise transient key, or PTK. So these temporary keys are created dynamically every time the client connects and is changed periodically. They're a function of the PMK, which is a random number generated by the AP, called an A-nonce. Another random number generated by the client, that's called an S-nonce. And the MAC addresses of the client and the AP. So the reason the keys are created from so many variables basically ensures that they are unique and non-repeating. So the four-way handshake, access point, and client are designed to independently prove their acquaintance with the PSK, PMK, without disclosing the key. So instead of disclosing the key, the access point, the AP, and the client encrypt messages that can only be decrypted using PMK. And if the messages are decrypted, they will learn about the PMK. So four-way handshaking is critical for the protection of PMK from malicious access points so that the client never has to tell the PMK to the access point. Within a handshake, GTK, or the group temporal key, is also used to decrypt multicast and broadcast traffic. So GTK is the key that is shared between all client devices associated with one access point. So yeah, for every access point, there will be a different GTK which will be shared between its associated devices. And then finally, the master session is the first key that is generated, either from EAPOL or derived from PSK authentication. Wow, I know it's a lot, but once we understand the important keys and how they're generated, well, we can then have a look at the actual four-way handshake with much deeper understanding. All right? So, let's work on it visually. Let's imagine an access point is configured with WPA2 PSK, and the device is trying to connect to it. So when the user clicks on the access point's SSID, so the access point sends an EAPOL message with an anonce, a random number, to the device to generate the PTK. The client device knows the AP's MAC address because it's connected to it. It has PMK, SNONCE, and its own MAC address. So once it receives anonce from the access point, it has all the inputs it needs to create the PTK. So once the device has created its PTK, it sends out SNONCE, which is needed by the access point to generate the PTK, as well as MIC, which is Message Integrity Check, to make sure that the access point can verify whether the message is corrupted or modified. All right, so once SNONCE is received by the AP, it too can generate PTK for unicast traffic encryption. So then the AP verifies message 2 by checking MIC, and if valid, it constructs and sends the GTK with another MIC. The STA verifies message 3 by checking that MIC, and if it's valid, the STA sends a confirmation to the AP. All right, so once the four-way handshake is completed successfully, now all unicast traffic will be encrypted with PTK, and all multicast traffic will be encrypted via GTK, which was created in the four-way handshake process. So WPA can be configured in two very different modes, pre-shared key and enterprise mode. WPA personal mode is appropriate for most home networks. When a password is set on a wireless router or an access point, it has to be entered by users when connecting to the Wi-Fi network. And in that personal mode, wireless access can't be individually or centrally managed. One password will apply for all users, and it should be manually changed on all the wireless clients once it's manually modified on the original wireless router or AP. So then the password is stored on the wireless clients. Therefore, anyone on the computer can connect to the network and also see the password. So enterprise mode provides the security needed for wireless networks in business environments. So it's a lot more complicated to set up because it offers individualized and centralized control over access to this Wi-Fi network. So when users try to connect to the network, they need to present their login credentials. This mode supports 802.1x radius authentication and is appropriate in the cases where a radius server is deployed. It might be a little too obvious, but I just want to let you know that WPA Enterprise should only be used when a radius server is connected in order to do the client authentication. Users will never have to deal with the actual encryption keys. They are securely created and assigned per user session in the background after a user presents their login credentials. So it prevents people from getting the network key from any individual computers. WPA Enterprise is more secure than WPA2 PSK because, well, the important thing to note about the personal mode is that all the clients will always encrypt their data with the same PMK every time. So it's easier to gather a lot of data encrypted with the same PMK. Now, should someone actually break the PMK, they could decrypt all the data encrypted with that key, past and or recorded in the future or real time. But otherwise, WPA Enterprise provides every client a different PMK instead of each client using the same PMK all the time, right? So it changes every session and association, and that seed is random as well as unknown. Now, should someone break a particular PMK, well, they only get access to that one session of that one client. They don't get access to the user's credentials since they were individually encrypted. That, of course, is a whole lot more secure. So let's have a look at detecting some of the encryption algorithms used by the device in Wireshark. So as you see here in the screenshot, the privacy bit of the selected device shows that it supports WP. There are no indications that the device is using WPA, so it's clear that it is using web encryption. In the screenshot, the details in the middle section of Wireshark also show that the device supports WPA encryption algorithms because there is a WPA version information here. And then if you look down a little further, there is WPA2 information. So obviously the device will support WPA2. Now, if you remember, WPA2 is also called Robust Security Network. So protocol details will be explained under the RSN information tag. So let's have a look at Wi-Fi protected setup, or what you might see as WPS. Sure, it's a standard for the easy and secure establishment of a wireless network. WPS is an optional certification program for Wi-Fi certified products. So not all Wi-Fi certified products will include some sort of WPS support. Users will need to look for the Wi-Fi protected setup logo or, some equivalent term on the product to ensure that the product is WPS compatible. So WPS automatically configures the network name SSID and WPA security key for the access point and the WPS enabled client devices on a network. You don't need to know the SSID and security key or even the passphrase when connecting WPS-enabled devices. No one can guess or figure out your security key or passphrase because the keys will be randomly generated. So there's no predictable passphrase or long sequences of hexadecimal to enter. Now, information and network credentials are securely exchanged over the air using the Extensible Authentication Protocol, or EAP. And that's one of the authentication protocols used in WPA2. However, yes, there are a few disadvantages. One, it doesn't support ad hoc mode or network where wireless devices are communicating directly to each other without an access point. And all of the Wi-Fi devices on the network must be WPS certified or WPS compatible. Otherwise, you won't be able to take advantage of the ease of securing the network in this way. Now, there are three primary methods used in Wi-Fi protected setup. There's a pin entry, a push-button configuration, and near-field communication. In all Wi-Fi protected setup networks, a unique pin will be required for each device to join the network. A fixed pin label or sticker may be placed on a device, or a dynamic pin can be generated and then shown on the device's display. In any event, the pin is used to make sure the intended device is added to the network being set up, and it'll help to avoid accidental or even malicious attempts to add unintended devices to that network. Now, in some Wi-Fi protected setup networks, the user may connect multiple devices to the network and then enable data encryption by pushing a button. The access point or wireless router will have a physical button, and other devices may have a physical or even a software-based button. And then during the usually 2-minute setup period, which follows the push of that button, unintended devices could join the network if they are in range. Then finally, a near-field communication interface, or an NFC, can be used to transfer network settings to a new device without requiring manual entry of its PIN. Make a note. The NFC method provides strong protection against adding an unintended device to the network, but I'll leave that as a ... Now, as with any penetration test, we need to do discovery in order to determine our target wireless network. We must also make sure that we're not targeting a network that we are not authorized to test. All right? That's as opposed to having a network connection. So it becomes a major problem when discussing wireless penetration testing, as you'll often find several wireless networks mixed with one target network. So it's especially true in situations where the target organization and its associated networks are located in an office building or, what do you call those things? The office park or compound or, well, you know what I'm talking about. Bettercap. So Bettercap is a powerful, easily extensible, easy to use, and all-in-one solution with all the features that might possibly be needed for performing reconnaissance and attacking Wi-Fi networks. So I'm also going to use Bettercap in the WPA cracking section. But in this section, we're just going to start the reconnaissance feature of Bettercap. So why don't we go ahead and install it? So first go to Kali, open the terminal screen and switch the user to root with the command sudo space su space dash. Then I'll run apt install Bettercap. And what do you think? It's that easy to install. Okay, so let's run Bettercap. And there's no problem. It's working properly. But we do need to give access to Bettercap in order to monitor all the network traffic. So first of all, don't forget to set the Wi-Fi adapter to monitor mode with the airmon-ng start WLAN 0 command. All right, so now we can monitor the Wi-Fi network traffic. Now run Bettercap-iface WLAN 0 mon. Type help Wi-Fi. And what you see here is that we're using a Wi-Fi module that is one of the modules in Bettercap, and there are lots of parameters to perform various Wi-Fi attacks, such as Wi-Fi reconnaissance, deauthentication attacks, and creating fake access points. Let's type Wi-Fi.recon on. So Bettercap starts to list devices and access points with SSID names, MAC addresses, signal powers. It also shows probe packets. So if we type Wi-Fi.show as a parameter, we can see the detected devices on a table. Now in this table, we'll also learn the encryption standard, channel, the client number connected to the device, the size of the packet sent and received, as well as the scene time. Cool. So after displaying this table, Bettercap continues to discover new clients until we type Wi-Fi.recon.off. All right, so now we're ready to start our configurations. The first step is to edit the GPSD configuration file. So just open up this file with a nano text editor on the terminal screen and add these options. Set them to false. In the second step, we'll need to edit the Kismet configuration file. So here I'll add NC source as WLAN0MON because the name of my Wi-Fi adapter interface is WLAN 0 mon when it's in monitor mode, right? But you, of course, should be using your interface name. So now add a local IP address with port 2501 as a listening address. And allowed hosts. So finally, in GPS configuration, there are a few differences here. So these are the options for the new GPS configuration of Kismet. Now we're only going to uncomment this line to enable GPS. So that way Kismet will get the GPS coordinates through GPSD. Now you will also need this Well, if you're French, it would be the WE file, but it's an OUI file for Kismet to properly identify MAC address vendors. So I'm just going to check and see if this link is still valid. Okay, so this link doesn't work. So again, we'll search on Google to find this file. Keywords will be Wireshark, MAC address, and vendors. Oh, there you go. See, Firefox has just been updated in the background, so I'll restart it. And I'll type the keywords again. Okay, so let's grab the very first website. All right, so here's a Wireshark manufacturer database. Okay, it's correct, so I'll use this list. Now run wget as the command with the O parameter. And we'll give a name to the output file, manuf, file saved. Okay, now copy it to the etc folder. So now we'll configure the Share GPS application on the Android phone. Before starting though, we must put Android in developer mode. So switching to developer mode may differ depending upon whatever device you have, so just find out how to switch into developer mode for your own device. If it just so happens that your phone is in developer mode, just open Share GPS, click on Connections, and add a new connection using the following settings. Click on Next and set the port to 50,000, so that's 5 and 4 zeros. Click OK. Now open the settings on the upper right corner. Settings must be the same as you see in the screenshots. All right, so go to Connections, and the connection that we added now is idle. So to connect it to the Kali machine, just tap on it to switch to listening mode. Now let's plug in the Android phone. So let's ensure that the wireless adapter is in monitor mode. And we'll also check the connectivity between the phone and Kali. Just type ADB devices. All right, so my phone is attached, but I need to trust Kali to change the unauthorized status. And for that, I just click Trust this device. Now let's check the connectivity again. Hey, we're okay. So now let's run this command and check to see if the GPS is working. Netcat, localhost, 50,000. And sure enough, this is GPS traffic. All right, so hit Control and C, and we'll turn on GPS-D and check with CGPS. Okay, so there's no GPS traffic here. So, right, something must have gone wrong. So we'll reboot Kali, try it again. All right, so here you see that I have rebooted Kali. I'll repeat some steps. Okay, so it's working now. Electrons are funny little buggers. But what we can do is turn on the GPS-D and check it out again. Okay, so now there's no problem. GPS traffic is coming from our Android phone. Now, before going ward driving, we don't forget to connect to the internet. All right, so let's just make sure that I use the internet on my Android. Okay, so if all the configurations are okay, the final step then is to just run the Kismet server. But before starting it, I'm just going to get into the car. Now, when you're in the car before driving, you run the Kismet server with this command. Just don't forget to change the Wi-Fi interface for your interface. All right, so now I am driving, and the Kismet server is detecting the Wi-Fi networks. Pretty amazing. We can always display the results with the user interface of Kismet from the browser. So open up this address. Of course, we'll need to create a user to log in with. And sure enough, here are the discovered devices. So let's have a look, see if the GPS is working. And yeah, the GPS values are saved by Kismet. Now at the same time, you'll see the GPS status on your phone. So sometimes the status will be no fix or 2D fix. If you want to get a really good view of mapping, though, it will be better for us to have a 3D fix. Then when you finish your route, you can press the keyboard command Control-C, and that stops the Kismet server. And then a Kismet server will be saved on the current directory. All right, so I've completed ward driving and collected enough information so that I can show you how to map. So it is now time to visualize the results. So I need to have a KML file, and that will import into Google Earth. Now, in this blog post, the GIS Kismet is used to convert netXML to the KML file format. However, in the new version of the Kismet tool, the file format generated as the result of scanning is already the Kismet format. So we have a Kismet file now. So that means we can convert this file to a KML file format with KismetDB to KML, which is a great tool. So we'll copy this part, and then we'll give the Kismet file with the in parameter, and we'll give a name for the new KML file with the out parameter. Okay, so of course there are warnings for certain Wi-Fi devices, but don't worry about that. Kismet did not find a good fix from GPS data for these devices. But these don't happen to be all the devices discovered, so there. So let's check the KML file. Okay, so look at this. A whole lot of coordinates have been recorded. So now the last step is to export this file to Google Earth. So to do this, we need to move this file to the host machine where Google Earth is installed. So first I'll just move this file to the desktop with the mv command. Okay, so it's here. So we'll drag it to the host machine. Now let's install Google Earth. You can search for it on Google if you don't have it. Click on the website, agree, and download. Okay, so click on the downloaded disk file. Double-click, install. And the install was completed. So let's go ahead and open it. File tab and open. Here it is, import KML file. Wow. So this approaching move to me is really exciting. I mean, here's my route and the discovered devices. So I can now examine all of the results a lot more closely on my visualized map. Pretty cool. All right, so a rogue access point is a wireless access point that's been installed on a secure network, but without explicit authorization from a local network administrator, whether added by a well-meaning employee or perhaps even a malicious attacker. So attackers can persuade clients to connect back to your attack system instead of attacking APs or trying to recover WEP or WPA keys. So this is where rogue access points come into play. So if an attacker installs an access point, they are able to run various types of vulnerability scanners. And then rather than having to be physically inside the organization, they can just attack remotely. So we'll see how rogue access point attacks work using different tools such as Airbase NG and Wi-Fi Pumpkin and Fluxion. CAR Metasploit is also a great function within Metasploit, allowing you to fake access points. But instead of that right now, I'm going to show you some newer tools such as Fluxion and Wi-Fi Pumpkin, developed for rogue access points. Airbase NG, of course, is not new. It was developed way back in 2008, but it's still a powerful tool that's been added to some of the new tools. Airbase NG is a multi-purpose tool designed to attack clients as opposed to attacking the access point itself. It also acts as an ad hoc or full access point. It has an ability to filter by SSID or client MAC addresses. You can manipulate and resend packets. You can also capture the WPA-WPA2 handshake. It also has an ability to encrypt sent packets and then decrypt received packets. But I'll tell you that the main purpose of the Airbase NG tool is to encourage wireless clients to associate with a fake AP and then prevent them from accessing legitimate ones. Airbase NG can easily spoil real nearby access points, so it's necessary to use filters so that you can minimize its impact. So why don't we go ahead and create a web access point, Airbase NG. Go to Kali, open a terminal screen and switch user to root with sudo su-. Check the mode of your wireless adapter's interface. Okay, so it's in monitor mode. And let's use AeroDumpNG to capture packets and find access points. AeroDumpNG will display a list of detected access points and also a list of connected clients. So we'll run AeroDumpNG WLAN 0mon. Alright, so I connect to Hacker Academy. Now we can learn important information about the access point in this list, such as channel, encryption type, MAC address. Now there's also a list that shows connected clients to access points. But now that we know the channel number, we can create a fake access point with Airbase NG on the same channel. So we'll use the C parameter to give the channel number, the E parameter to give an ESSID with the same name as the access point. The S parameter is used to force shared key authentication. Uppercase W is used to set the WEP flag in beacons. And then at the end of this command, we should add the wireless interface. Alright, so now a fake access point was created with this MAC address. So copy the BSSID. I'll open a new terminal and run AeroDumpNG to see only the information about this access point. We'll give the channel and the BSSID of the access point. And as you can see, the encryption type of the fake access point is WEP, and it is on channel 11. And, of course, right now there are no data packets because there's no connected client to this access point. But it is propagating beacon signals. You can see its SSID with WEP encryption on the other devices. So when a client attempts to connect to the fake access point, you can see the logs on the screen. Now, we didn't set a WEP key, and we don't know the shared key right now, so we could not authenticate to this particular access point. Therefore, there are broken shared key authentication errors in the logs, right? Now, in the WEP cracking section, I'll set the WEP key with the lowercase w parameter to show you how to crack the WEP key. So right now, let's look at the AeroDumpNG screen. And although we could not authenticate with a fake access point, we can certainly see the MAC address of the device in this list when it attempts to authenticate. So a variant of the fake AP attack is when the attacker mimics the settings of a legitimate AP to create a virtually identical AP called an evil twin. Appropriately named, I'm sure. So the SSID of both the legitimate AP and the fake AP is exactly the same. So now in this lecture, we're going to create an evil twin access point by giving the IP address to the client that will attempt to authenticate to the access point. And then in this way, we'll see the network traffic of the client. And actually, we're going to perform a man-in-the-middle attack as well. So let's start her up. Go to Kali, open up a terminal screen, switch user to root with the command sudo su-. check the mode of your wireless adapter's interface. If it's in managed mode, change it with the airmon-ng start WLAN 0 command. And we'll kill the other wireless interfaces. Alright, so now I'll create a fake access point with airbase-ng. This time I'll create a fake access point with open authentication to authenticate without a key. So for that, we'll open a new terminal. Now we'll install DNS Mask. That provides domain name system or DNS forwarding. Now, as you should already know, DNS is responsible for resolving name queries, which allows us to serve the World Wide Web. I don't know, does anybody still call it the www or the www? But anyway, that's how we visit websites, right? So the DNS Mask program assists in providing DHCP clients access to the internet just by forwarding their DNS queries to actual DNS servers or recursive resolvers of our choosing. All right, so we'll install DNS Mask with apt install DNS Mask. Of course, I already have it. DNS Mask comes with its own dnsmask.config file stored in the /etc/ folder. And we can view this configuration file just by executing the nano /etc/dnsmask.conf. So we need to add some parameters in this config file. Write the parameters that I wrote here into your own config file. And then use a keyboard command, Control-S to save and quit with Control-X. So airbase-ng sets the fake access point on interface at 0. So we must bring this interface up, configure it, enable IP forwarding, as well as a few other parameters. So first we'll run if config AT0 up. So it brings up the AT0 interface. Secondly, if config AT0 10.0.0.1 netmask 255.255.255.0. And then that sets the AT0 interface IP address as 10.0.0.1 and then the submask as /24. Route add -net 10.0.0.0 netmask 255.255.255.0 GW 10.0.0.1, and then that'll create a static route in our routing table so that any traffic from our clients will be forwarded to the real gateway at 10.0.0.1, which is actually part of the 10.0.0.0/24 network. So IP tables -p forward accept creates a policy to accept forwarding in the chain target. Now, this makes our Linux machine act like a router. IP tables -tnat -a post routing -o WLAN 0 mon -j masquerade. That allows us to route outbound traffic without disrupting the normal flow of traffic on the network. The masquerade option kinda acts like a source NAT. Echo 1/proc/sys/net/IPv4/IP forward enables IP forwarding. The 1 just enables the IP forwarding, while a 0 will disable it. All right, so we'll save these commands to a text file. And when you create a fake access point in the web cracking section, we'll use them again. All right, so we're ready now. So we will run DNS Mask using the config file. So we'll execute DNS Mask -c/etc/dnsmask.conf-d. And then we'll connect to this access point with a phone. So see, when I connect to the fake access point, logs appear on the screen, and then DNS Mask gives an IP address of the device. Okay, so I Actually, don't know why right now, but it didn't give the IP address to Xiaomi. So I'm going to just try and connect with the iPhone. Okay, so as you can see, I am able to monitor iPhone traffic. All right, so Wi-Fi Pumpkin is a powerful framework for rogue access point attack. Written in Python, it will allow, and it actually offers security researchers, red teamers, and reverse engineers to mount a wireless network in order to conduct a man-in-the-middle attack. So, firstly, Wi-Fi Pumpkin was written with Python 2.7. So it had a user interface, but it deprecated, and Wi-Fi Pumpkin version 3 is now what we use. So once you start up the tool with sudo, you'll be presented with an interactive session, kind of like the Metasploit framework, where you can enable or disable modules, plugins, and proxy configure the access point. So let's start to install. Let's go to Kali, open the browser, search Wi-Fi Pumpkin 3 for the GitHub page. Click on the Wi-Fi Pumpkin 3, and let's take a quick look at the GitHub page. So here you've got the main features. We can perform not only rogue access point attacks, but also the other different network attacks are listed, okay? All right, so we have the appropriate platform for this tool to work. So we'll click for the installation. Scroll down a little bit for the installation procedure for Kali Linux. Now let's install the dependencies. So switch user to root and run the command. So here you can notice that I already have the dependencies. Okay, so the next step is to clone the repository. We'll change directory to Wi-Fi Pumpkin. The other dependency is PyQt5. Copy this command, paste it. Now we can check if the installation is successful by running this command. All right, so we can see it's done. So we'll install the setup file. And that shows the installation is complete. So let's run Wi-Fi Pumpkin 3. Oh, I got an error, did you? So I'm going to look at the requirements file. So I need this package, but to make sure that I have all the packages, I'll just run the pip install-r requirements. All right, so now I'm going to run Wi-Fi Pumpkin again. I forgot to set it up again. That's okay. So after getting the new packages, we'll just set it up again. See, so now it's okay. All right, so I have shown you, and I have I have just shown you, I mean to show you these kinds of little quirks that happen, right? But we've now successfully installed Wi-Fi Pumpkin 3, and we are ready to create a fake access point. So, open up the terminal screen, and we'll check the mode of Wi-Fi interface. So this time don't have to switch it to monitor mode, but just run Wi-Fi Pumpkin 3. Let's type help to see the available commands. Okay, so it gives us the access point commands. So to create a fake access point, the commands that we need to write are set interface WLAN 0, set SSID Hacker Academy, and the SSID should have the same name as the access point for which you want to create a rogue access point. So Wi-Fi Pumpkin has 3 types of proxies to redirect all traffic with IP tables. But I'm not going to use a proxy for now. So I'm going to set proxy no proxy. Ignore the PyDNS server, as we're not going to see any login console. And start. So a fake access point is created, and the request packets are coming from the clients, and they will appear on the console. I connect to the access point with my phone. As you can see, the sniffer in Wi-Fi Pumpkin is showing the traffic. So if you type clients in the console, you will see the connected clients on a table. All right, so now press Q to quit. We'll look at the processes in the background with the jobs module. So to stop the access point, just type stop. All right, so let's look at the available proxies and plugins. So proxies work by intercepting a request, modifying the request if necessary, then handling or forwarding the request to its destination. So when a user connects to the access point, the transparent proxy intercepts the request before passing it on to the provider. So the plugins basically add features, and Wi-Fi Pumpkin provides facilities to develop our own plugins. Now, if you have a look at the documentation and have a few minutes on your hands, you can have a look through Wi-Fi Pumpkin and you can perform very complicated attacks using these features. Fluxion is the final tool that I will use for a rogue access point and a man-in-the-middle attack. Fluxion is a security auditing and social engineering research tool. So it attempts to retrieve the WPA2 key from a target access point by means of a social engineering attack. Now, we've all read about them, but there are 2 types of attacks within this tool. There's the handshake snooper and the captive portal attack. The handshake snooper. This is an attack that attempts to retrieve the 4-way handshake. The captive portal attack attempts to retrieve the target access point's WPA2 key by means of a rogue network with a border authentication captive portal. So, let's start. Go to Kali. Open up the browser. Search for Fluxion. Open the GitHub page of Fluxion, and let's take a quick look at this GitHub page. So requirements are Linux and external Wi-Fi card, okay. What we'll do is we'll clone the repository as our first thing. So we'll copy the HTTPS link and then run git clone with this link. And change the directory of Fluxion and list the files. Execute the bash file to install. And of course, it must be run with sudo. Now, there are missing dependencies, so let's add an I parameter so that we can install them. And the installation process may take some time. All right, so here it's completed. So we'll enter the number of the language that you want to use. Okay, so now we're ready to attack. The handshake snooper attack attempts to retrieve WPA2 authentication hashes, which is otherwise known as a 4-way handshake. And then we can use that later by the captive portal attack for key verification. So the captive portal attack will require the handshake.cap file from the target access point. We do not have the .cap file, so we must first complete the handshake snooper attack. All right, so let's go. Go to Kali, open the terminal screen, and we can see the status of the adapter with the iwconfig command. So its mode is managed for now. So we can enable monitor mode. I hope you've already done it, right? Just enable with airmon-ng. Okay, it's in monitor mode. And we'll change directory to Fluxion. So execute the bash file to run Fluxion. And select the handshake snooper attack. Now select the channel of the access point that we want to create a fake access point for. So if you don't know the channel, then select 3. It will list all the access points for channels between 2.5 gigahertz and 5 gigahertz bandwidth. My access point is on channel 11. So if your target access point appears on this screen, just close the scanner with key command Control-C. Enter the number of the target access point. Okay, so now we can select the wireless interface WLAN 0. And again, we'll select the same interface for our fake access point. Now, to force the client to reconnect to the access point, Fluxion will perform a deauthentication attack. It's a passive method of attack, and it forces the radio to go completely silent, making the attack undetectable, and then it allows for better listening. So this method should work best in situations where the target is pretty far away. So an aggressive method of attack uses a deauthenticator, either AirPlay-NG or MDK, and sends deauthentication packets to the target access point's clients. So this method is cutting the connection between the client and the access point. And then once the connection has been broken, some devices will automatically attempt to reconnect, sending a 4-way handshake, which Fluxion's radio could catch. Now, this method really, legal disclaimer, this method really could be considered illegal. So I want you to make sure that you're following whatever governing laws apply to you. You need to be aware of all of that. We are not liable for your irresponsibility. So that being said, I'm attacking my own access point for educational purposes, so I'll just select AirPlay-NG as a deauthenticator. So now we need to select a hash verifier, and it'll be used when a valid hash is captured. So I select the recommended tool, which is Cowpatty, and I'll just select 60 seconds for this. You can always select the recommended option. So it sets how verification occurs in relation to capturing data, either simultaneously, asynchronously, or back-to-back, synchronously. And I will select synchronously. All right, so finally the attack is started. So there are 3 screens. In the upper left screen, the handshake will be captured. In the lower left corner, there are log messages about the activities performed by Fluxion in the background. And in the lower right corner, AirPlay-NG performs deauthentication attacks to force the clients to reconnect to the access point. Now, at this stage, we have to be a little patient until the handshake gets caught. The client connected to the access point right now. Okay, great. So the handshake snooper attack is now complete. Looks like Fluxion caught a valid hash and saved it to Fluxion's database. All right, so the good news is we have a valid handshake from the handshake snooper attack. Now we can set up to perform a captive portal attack. And that's also the good news. All right, so go to Kali, open the terminal screen, change directory to Fluxion. So let's check if the handshake is saved in Fluxion's database. We know it should be. List folders and files with the command ls. Change directory to attacks, handshake snooper, handshakes folder. List files. All right, so you're looking at the captured handshake. So go back to the Fluxion folder again. Run a bash file with sudo. Select Captive Portal Attack. Now select the channel of the access point that we want to create a fake access point for. So if your target access point appears on this screen, just close the scanner with Control-C, enter the number of the target access point, and I will select the wireless interface. All right, so here I'm revealing all my secrets. I've used this before for this attack. Therefore, the configuration's been saved, so I'll just select Reset Attack. So we'll select the same interface for the fake access point. And this time, I would like to try the MDK4 method for deauthentication. So now we need to select an access point service for the rogue access point. Okay, so I'll continue with the recommended option. So I'll select Cowpatty for password verification. In this step, Fluxion has detected the hash file previously captured by the handshake snooper attack. So just select Use Hash Found. So again, I'll select Cowpatty for hash verification. All right, hash verification is successful. Now, you must be aware that SSL TLS is a method of encryption used to establish a secure connection between 2 points. In this case, the 2 points are the captive portal's web server and the target client. Now, if you don't have a personal certificate, you may select to automatically generate one. So just select Create an SSL certificate. Now you can select whether the captive portal web server should attempt emulating an internet connection. This could be useful for people that don't want to make the captive portal obvious. The clients will connect, but access any website. Right, that makes sense. So that means I'll select the disconnected option. Now in this step, we'll select a captive portal interface for the rogue network. I'll continue with the English generic portal. Okay, so the attack begins. And this time there are 6 terminals on the screen. So the terminals above, from left, Fluxion DHCP service to give an IP address to the connected client. Fluxion host APD, so it's a service to create a rogue access point. And Fluxion access point authenticator that displays the authenticated clients to the access point. And the terminals below, from the left, are Fluxion DNS service, and that provides access to the internet by forwarding clients' DNS queries. Fluxion web service, and that will listen to the web traffic of the connected client. And Fluxion jammer service for deauthentication attacks. Okay, so my phone authenticated to the access point now. And DHCP service offered an IP address. It's disconnected and reconnected again. Cool. So finally, web traffic appears on the web service. So I am listening to the traffic, and the man-in-the-middle attack is completed successfully. Good job. All right, so finally it's time to start attacking encrypted wireless networks, now that you got the hang of it. Although web encryption is not acceptable due to, of course, some of the security reasons that we've already talked about, many corporate environments are still using web encryption in their wireless networks. Right? Well, keeps us all with a job. So, in conducting these attacks, we will have the opportunity to see more of the available attack modes in AirPlay NG, as well as how to leverage KRACK to crack web keys. Now, as each new tool or technique is revealed and encountered, we'll thoroughly introduce it before putting it into practice. So the first step in every attack scenario is to place the wireless interface in monitor mode on the channel number of the access point. You've probably already done that. I hope you have. Well, now you're going to. So go to Kali, open the terminal screen, and switch user to root. Then check the mode of the wireless interface. You can also check with the ifconfig command. And yeah, it's in monitor mode, so we'll open a new terminal screen. Now before we start web cracking, we need an access point with web encryption. Now, as I showed in the rogue access point section, we'll create an access point with airbase ng, and this time we'll set a web key with the lowercase w parameter. All right, so I've entered a 10-digit hexadecimal value with ASCII equivalent of 12345. I will run DNS mask and do the interface configuration. I save the configuration settings to a text file in the rogue access point section, so I can just copy and paste them into the terminal. And now DNS mask is running and our access point is ready to hack. Now, as you see, I connected to the access point with my phone. So then the next step is to start the arrow dump session. So arrow dump ng is used for packet capturing of raw 802.11 frames, and it's particularly suitable for collecting web. So here's my fake access point. Hello. Now, the fake authentication attack allows you to associate to an access point using either of the two types of web authentication, the open system and shared key authentication. Although it's not strictly required, most of the attacks in this course will start with a fake authentication to the victim AP, and that's in order to be able to communicate with it. Now, before we can inject packets into a router, we have to authenticate ourselves with the router. And to do this, we use fake authentication. So this attack is useful in scenarios where there are no associated clients and you need to fake authentication to the access point. So let's get started. We'll check the mode of the wireless interface. Now, before switching to monitor mode, we do need to know the BSSID of WLAN0. Type ifconfig and copy the MAC address of WLAN0. Then when you want to anonymize yourself, you can change or fake your MAC address so your original MAC address will be hidden. To do that, you can use a tool called MacChanger, which happens to already be present in Kali Linux. So just type MacChanger-R WLAN0. But we do need to bring down WLAN0 first before changing the MAC address. All right, so it's changed now. And this is the new MAC address. Type ifconfig WLAN0 up to run the interface again. All right, so let's double check it with ifconfig. Okay, so that looks correct. Now we can switch the wireless interface to monitor mode. Open a new terminal screen. And let's start an arrow dump ng session just for this access point. So on this command, we'll specify the channel with the C parameter, MAC address of the access point with BSSID parameter, and the file name with -w, and interface. All right, so now we can start the fake authentication attack. Run airplay ng with the fake authentication parameter and 0. So 0 means the reassociation timing in seconds. Here it will associate one time every second. We'll also add an E parameter to give the ESSID of the access point, A parameter to give the MAC address of the access point, and then finally we'll give the MAC address of the WLAN0. Now, according to the AirPlay output, the fake authentication was successful. And looking at the running of AirDumpNG capture, we can see that our MAC address is now displayed as being associated with the access point. All right, but we're not actually connected, but we are authenticated with the network and have an association with it. So that way we can inject packets into the access point. It will now receive any request that we send to it. So AirPlay-NG's deauthentication attack sends disassociation packets to one or more wireless clients currently associated with an access point. So by performing this attack, we will transmit 128 deauthentication packets, deauthenticate the client from the access point, as well as the access point from the client. Then the client will lose network connectivity and then reassociate. All right? You got it. So let's start. Our fake access point is still running, so we'll start an AirDumpNG session. And as you can see in this list, my phone is associated with the fake access point. So we'll start an AirDumpNG session for the fake access point. I'll perform the deauthentication attack on the right terminal. So the argument that I'll give with the deauth parameter is a count for the number of times to perform the attack. So each attack will consist of 64 packets from the AP to the client and 64 packets from the client to the AP. Now, if you send a large number of packets, it will be a denial of service attack against that access point. So I'm just going to give 0 for the packet number, and it will continue to send packets until I stop the session. You can stop the session just by the keyboard command Control-C. The destination address is specified with C and the BSS ID with the A parameter. So we'll copy the MAC address of the client. And we can tell from the data packets whether the client has been deauthenticated or not. If the data packet numbers do not increase, the client is deauthenticated. If the deauthentication attack does not work, there could be several reasons. Could be you're physically too far away from the client. You need enough transmit power to reach the client. That might be obvious, but you never know. Wireless cards work with particular modes, such as B, G, N, etc. So if your card is in a different mode than the client may not receive your transmissions. Now, clients could also reconnect too fast for you to see that they have been disconnected. You can always look in the packet capture for reassociation packets to confirm that your attack worked. We can also perform a deauthentication attack with Bettercap. You might remember that we installed it earlier in the wireless reconnaissance section. So just go to Kali, open the terminal screen and switch user to root. Start Bettercap with the interface parameter. Run help Wi-Fi to see all the available modules. Okay, so here is the deauthentication module. We'll provide BSS ID of the access point and every client will be deauthenticated. So first let's run Wi-Fi.recon and we'll see the access points. So let's show the table with Wi-Fi.show. And we can start the attack. So type Wi-Fi.deauth and the BSS ID of the access point. So right now, Bettercap is sending the authentication packets against the connected clients. Oh, and by the way, Bettercap also captured the WPA handshake easily while Wi-Fi reconnaissance is in progress. So we're going to use that later in WPA cracking. Now the final AirPlay attack is the ARP request replay attack. I'd say this attack is the most effective way to generate new initialization vectors. The initialization vector is a continuously changing number used in combination with a secret key to encrypt data. So the attack listens for an ARP packet and then retransmits it back to the access point. So this causes the access point to repeat the ARP packet with a new initialization vector. Then by collecting enough of these IVs, KRACK can then be used to crack the web key. The Address Resolution Protocol, or ARP, is used to convert an IP address into a physical address, such as a MAC address, right? So a host that wishes to obtain the physical address of another machine sends an ARP request broadcast on the network. The host with the matching address replies with a unicast transmission and reveals its physical hardware. All right, so that sounds simple enough, so let's get started. For this attack, your wireless card needs to be in monitor mode, and you will need a fake authentication with the access point, as I showed you in the previous lectures. So I set the fake authentication time to 60 seconds, and it will associate again every 60 seconds. All right, so my fake access point is up. Now I'll open a new terminal screen and start ARP replay attack. So give ARP replay attack parameter BSS ID of the access point and the MAC address of the associated client from fake authentication. And let's run it. So right now it's sending ARP request packets to the access point. After launching the ARP request replay attack, you might have to wait a couple of minutes or even longer until an ARP request shows up on the network. Then once one is received, the ARP request replay attack will jump into action and start replaying the packet over and over and over again, forcing the access point to generate new initialization vectors. So yeah, the process usually takes some time. So this is where the deauthentication attack comes into play. When a client is deauthenticated and then reconnects to the wireless network, there's a very high likelihood that it will send an ARP packet as it reconnects. So let's start a deauthentication attack to speed up the process. Yeah, we can wait for a bit. I'll stop the deauthentication attack. And let's try to crack the web key with KRACK. So we need to provide the file captured by AeroDumpNG to KRACK. And now run KRACK and we'll give the captured file. And KRACK is trying to crack the key with the initialization vectors. Yeah, this process also takes some time, so please be patient. But look at that, the key has been found. KRACK found the web key by using 38,730 initialization vectors. Not too shabby. So now it's time to crack the web key for clientless networks. Because I know what you were thinking. Okay, fine, this works, but what about clientless networks? Well, KRACK has two attacks, the chop and the fragmentation attack, and these can be used to crack the web key of a wireless client with no associated clients. Now, both of these attacks are used to obtain a PRGA file from the wireless network. So PRGA is the pseudo-random generation algorithm that's used to generate the key stream that's used in web. It's not the web key, right? So it cannot be used to decrypt packets. It can, however, be used to create new packets that can later be used for injection. There's a method to our madness. So the first technique we're going to use to obtain the PRGA file is the fragmentation attack. Fragmentation attack requires at least one data packet to be received from the AP in order to initiate the attack. But before getting started with this attack, I want to make sure that there are these known assumptions in your minds. First off, may be obvious that you are close enough to the AP to send and receive packets. But just because you're close enough to receive packets doesn't necessarily mean you'll be able to transmit packets to the access point. You can work that out on your own or practice. Now, there are some data packets coming from the AP, so a quick way to check for data packets is to run arrow-dump-ng and then see if the data field is increasing. And of course, the AP needs to be using web open authentication. Great, so let's start. And as usual, our wireless card first needs to be placed into monitor mode on the channel number of the access point, and a fake access point with WEP and open authentication needs to be running. Now we need to start an arrow-dump-ng session, and we're filtering on the access point channel and BSSID so that we can save the capture to a file. Now notice in the arrow-dump output, there are no clients associated with the access point. So in order to be able to communicate with the access point, we need to conduct a fake authentication attack against it. And we will run the fake authentication with a reassociation timing of 6,000, so it does not time out. You with me? Cool. So now AirPlay will keep the session alive so we don't need to worry about relaunching the attack every time the fake association times out. So the fragmentation attack requires at least one data packet to be received from the AP in order to initiate the attack. And we have one data packet now. So let's open up a new terminal window, and we will launch the fragmentation attack against our AP using the basic syntax. So I'll give BSSID of the access point with the B parameter and the MAC address of the WLAN0 with the H parameter. Okay, so AirPlay NG is starting to send packets. So the attack sends out a large number of packets, all of which must be received by the AP in order for it to be successful. Okay, so therefore you have to have a good quality connection, like I was saying before, and be reasonably close to the AP. All right, so once we launch the attack, AirPlay starts listening for a packet to use, and then when a candidate's found, we are prompted to use it for the attack. Okay, so now a candidate packet is found. Just enter Y and wait for it. Okay, so sometimes this happens. Unfortunately, the fragmentation attack did not work. And naturally, there are several reasons why this could be. The attack may fail against access points that do not properly handle fragmented packets. But do not give up, because there is an alternative way to crack clientless web networks. That's where the chop-chop attack may work, where the fragmentation attack may not. Okay, great. So in the previous lecture, the fragmentation attack was attempted and not successful. So, before you give up, you got to try another method to crack the web key for clientless networks, and this time we will use AirPlay Attack 4, which is otherwise known as the chop-chop attack. So the chop-chop attack, when successful, can decrypt a web data packet without knowing the web key. Now, there's a tiny difference from the fragmentation attack. We only need to change the attack number. It'll be 4. So let's check the data field in the arrow-dump session. Okay, so we do have one packet now, and there is an associated client with fake authentication. Sometimes you have to wait for a long time, or so it would seem. Now, as for the fragmentation attack, the chop-chop attack saves the key stream into an XOR file that can later be used to generate a packet with packet forge ng. Okay, so the capture file and key stream file are now saved. So at this point, we need packet forge ng, and that is used to create the encrypted packets that can later be used for injection. So we use packet forge ng to generate an ARP request packet that we'll later use to attack the wireless networks. So the syntax that we're going to use here is packet forge ng 0, MAC address of access point, and let's copy it from here. MAC address of the client. I'm copying that from here. Destination IP and source IP. XOR file and output file name. And now the forged packet is saved. So now I can start an ARP replay attack by using this packet to increase data frames. Well, okay, there might always be something. It might always not be, but I didn't, in case you didn't catch it, I did not add the BSS ID, so make sure you do. It has to be used with the B parameter, of course. Okay, so as you see here, the data packets are increasing. And after waiting for a while, we can run KRACK-ng. And for that, we've got to give the arrow-dump-ng output file to the KRACK-ng. It might be a little while again. So sometimes it may be necessary to terminate and then restart KRACK-ng. Sometimes it breaks the key, but it might not show on the screen. And yeah, okay, so the key was finally found. Very cool. So in this section, I will show you the techniques used to crack Wi-Fi network passwords with WPA, WPA2 protocol. In the Wi-Fi network interaction section, we learn some background to better understand what WPA, WPA2 is. You might need to review it, or you can continue. But just to refresh your memory, there's an important difference between cracking WPA and WPA2 and WEP. Now, this is the approach used to crack the WPA and WPA2 pre-shared key. So unlike WEP, where statistical methods can be used to speed up the cracking process, only plain brute force techniques can be used against WPA and WPA2 because the key is not static. So collecting initialization vectors, like when you're cracking web encryption, is not going to speed up the attack. The only thing that does give information to start an attack is the handshake between client and AP. Now, there isn't really a difference between cracking WPA or WPA2 networks. The authentication methodology is basically the same between them, so the techniques are, well, I'd say identical. So it's important to use a brute force attack approach during an attack because cracking the WPA2 encryption algorithm is very computationally intensive. A computer can test maybe 50 to 300 possible keys per second, depending on the computer CPU. So this process can take days or sometimes hours. Don't want to discourage you, but you will need a word list that will cover all permutations and combinations of characters and special symbols. So a word list, or a password dictionary, is a collection of passwords stored in plain text. It's basically a text file with a bunch of passwords in it. One of the most important points before starting WPA attacks is password lists that you will use during key breaking. It's very important to have a strong list in order to minimize the amount of time that you're going to spend cracking. Therefore, beside the word lists you can find all over the internet, there are some built-in word lists in Kali. But first, let's take a look at some of the word lists on the internet. So go to Kali, open the browser, and search password word lists. So let's click on this GitHub page. So this repository is commonly used for password cracking. It includes a number of very popular lists, including the RockU lists. I don't know if you've heard of those. So we'll take a quick look now. So here's a folder that includes the Wi-Fi WPA passwords. Let's open it, and there are the top passwords in these lists. So you can choose whatever you want according to the password number. Let's open one of them. Okay, so as you can see, it contains simple passwords as well as the most used ones, but there are also some complex passwords. So let's look at some of the other password lists on Google. Yeah, let's have a look at this website. Now, there are word lists with the rate and size information here. So let's go back. There's another popular website that includes password dictionaries and leaked passwords. Add skull in the search bar, and we'll click on the first website. So you can also download these popular password dictionaries from here. Now, these passwords were all collected from leaked or stolen repositories from different websites. Okay, so you can select whatever list you want. I'll download Daniel Miesler's list because we looked at that first, but also I know what's in there. So we'll go back to the GitHub page, click on the sec list, and copy the link. Open the terminal screen, and we'll clone the repository. All right, so now we have taken our most important weapon. We can start these attacks. So we're going to start to crack the WPA key with KRACK. First, we'll need to capture handshakes and run the KRACK with a handshake file and a word list. So we'll go to Kali, terminal screen, switch user to root. Check the mode of the wireless interface. It's in managed mode. So, of course, you know that it needs to be placed into monitor mode on the channel number of the access point. Open a new terminal screen and start an arrow dump session. Okay, so here's my access point. Start an arrow dump ng session for the access point, and we'll give a name for the output file with a W parameter. Okay, so it started. Now at this point, we'll need to capture a four-way handshake. So to speed this process up, you can always start a deauthentication attack or reconnect to the access point with your phone. All right, so it looks like it has captured the handshake now. And you can see in this section here that we've got it. So now we'll start the KRACK with this captured file. And we will need to add a dictionary. So this time I'm going to show you a word list that's already in Kali instead of using seclist. So I'll open a new terminal. Change directory to user, share, word lists, and Metasploit, and list the files. A Metasploit comes bundled with word lists. Note that these are much smaller and mostly contain factory default or trivially simple user name and password combinations, but you'll see the point. The principal utility of Metasploit word list consists of its matching of usernames and default passwords with services. I'll use the password.lst file, so let's open it. So here are the multiple password combinations. Now, I do want to point out here, though, that the purpose of this course is to show you how to use the necessary tools and how to crack the key, because key cracking can take a long time, so that's why I've added my password to the list. I'm not going to sit here and have you watch hours and hours of attempts. Okay, so now we can give this word list to the KRACK. First, copy the full path from here, paste it, and add the file name. All right, so it started. Okay, well, key not found. In your face. So that's the first try. It might not find the key. So we do need to try it again. And there it is. Now it's completed. The key has been found. So AirCrack NG is great at guessing WPA passwords, but it does require very large word lists in order to cover a wide range of possibilities. I mean, that makes sense. John the Ripper, or JTR, is an exceptionally fast password cracking program, and it's supported on most operating systems, and it includes customizable word mangling rules that can essentially expand your word list without any additional effort. For instance, if your word list contains a lowercase password, let's just say of password, John the Ripper's rules will try password and password 1, etc., any sort of variable of that. So with very little effort, you can leverage all the powerful mangling capabilities of JTR and then feed them into AirCrack NG, and that broadens your password cracking capability. Okay? So let me show you how it works. Go to Kali, open a new terminal, and we'll look at the parameters of John the Ripper. Just type in John. Excellent. So here we can enable rules with this parameter and also add rules to the configuration file of John the Ripper. Change directory to user, share, John, and list the files. Now open the john.conf file with the nanotext editor. Scroll on down. This file's very long, so you know what? Let's just search the rules section. Press Ctrl-W and type rules. Now there are dozens of rules created with numbers and symbols. You can also add your own in here. So let's add a new example rule. Let's add the rule to the word list section. Go to the end of the section and add new rules that match passwords with a digit of the last 2, 3, and 4 characters. And make sure that you save it. Ctrl-S to save, Ctrl-X to quit. Now we'll go back to this terminal. Type in John and give the full path of the word list. This time I'm going to use the rocku.txt file. So let's find this file and get the full path. Change the directory to user/share/wordlists and list files. So here is the rocku file. Type the full path of the rocku.txt and the rules and the std out parameters. And finally, we'll run the AirCrack NG with ESSID of the access point and captured file. Oh, wait. I'm missing something. So let me just check the word list and capture the file quickly. Okay, so I understand it now. It's very small but important detail. And let me show you, you might have caught it. We need to add a dash symbol here. All right, see how it's working now? Now we just have to wait. All right, so the key was found. See? Finally. Good job. Cowpatty is a versatile tool that can recover WPA pre-shared keys using both dictionary and rainbow table attacks. Although it's not being actively developed, it is quite useful still, especially when using its rainbow table attack method. So for this reason alone, it's worth adding to your arsenal of tools. So since Cowpatty does not include a sniffer component, it still requires a WPA handshake to be captured with an external tool such as AeroDumpNG. So I'll just use the handshake file that we previously captured. So go to Kali, and first we'll type Cowpatty to see the parameters. And we'll give it a dictionary file with the F parameter. Now I'll use the rainbow table attack of Cowpatty. So the main purpose behind using Cowpatty is to make use of pre-computed hashes, similar to AeroLibNG, to crack WPA passwords. So it's by using these pre-computed hashes, frequently called rainbow tables, This will significantly reduce the time required to crack WPA passwords, as all of the computation is done ahead of time. So, that means we first need to generate the hashes for our ESSID, along with a dictionary file containing passwords. Now, Cowpatty includes a tool, GenPMK, and this can be used to generate the required rainbow tables. It also has the following syntax: GenPMK F, the full path of the dictionary file, the file to save the computed hashes, and the network ESSID. Far out, now it's creating the hash file. It's okay. So it's time to run Cowpatty using the capture file and generated hashes. And I'll also add the to-parameter. It's a non-strict mode because Cowpatty has an issue with error dump captures. So finally, add the network ESSID and run it. Maybe this parameter is no longer used. So let's delete it and run it again. Oh, Cowpatty found the key very quickly that time. All right, so in this lecture, we will use Wi-Fi TE to crack WPA networks. Wi-Fi TE is an automated wireless attack tool. It was designed for use with pen testing distributions of Linux, such as Kali Linux. We don't need to install it because it's already installed in Kali. In fact, let's go to Kali and find out. So we'll open up the menu and click the wireless attack section and Wi-Fi TE. All right, so these are the parameters. We can also perform web and WPS attacks with Wi-Fi TE. I'll use it for WPS again. But now let's start a WPA attack. So we need to add a dictionary besides the WPA parameter. Just type sudo Wi-Fi TE WPA -- dict and then copy this path for the dictionary. I only copied half it, so it's not a problem. We'll just continue. And when you see your access point on the list, just keyboard command Control-C. Now we'll enter the number of the target, and just like that, the attack started. And yeah, it's captured and saved the handshake. So it finished attacking because I gave the wrong dictionary parameter. It's not a problem. Just open a new terminal screen and we'll first check the handshake again. And now we can crack this capture file with a KRACK parameter. Enter the number of the handshake. Enter the cracking tool. I'll select KRACK. Boom! The key was found. Wi-Fi TE used this dictionary as default, and it cracked the key pretty quickly, wouldn't you say? Now in this lecture, I would like to show you cracking WPA2 with GPU using Hashcat. So in the previous lectures, we used CPU as the primary part of the calculations of the keys. And yeah, it surely does give a speed for WPA2 cracking. While using keys for cracking, we are not performing actual calculations in real time. Still, even if this does give us any kind of speed, this method is, it's a bit slow. So, here's what you need to stop using your CPU and test the processing power of your GPU. Yeah, GPUs can be used for WPA2 cracking password hashes, and are being used now for, quite a while. Because the CPU has 2, 4, or maybe 8 cores and parallel computing units, and GPUs have thousands of them. Of course, there would be many tools that use GPUs like Pirate to increase WPA2 cracking speed, allowing you to crack in much less time than your CPU. So what we'll do here is use Hashcat. I'm going to use it in this lecture on my host machine. Just because VirtualBox doesn't support accessing the CPU on the host machine, so we'll need to run Hashcat on the host machine and send instructions to the GPU, not the CPU. I'll show you how it works. So let's start. Open the browser and type hashcat. Go to the website of hashcat. Now if you use Windows, you just download hashcat here with a download link. And these are the GPU requirements list. So if you're a MacBook kind of user, let's have a look at the GPU of the MacBook. In the upper left-hand corner, just click About This Mac, System Report, and Graphics. And here you can see that my graphic card model is AMD Radeon Pro 5300. It's certainly compatible with hashcat. So let's go back to the website. These are the features of hashcat, and it's very fast and advanced password recovery utility, supporting 5 unique modes of attack for over 300 highly optimized hashing algorithms. So we'll start to install it. I'll just search for macOS installation. And look at that, there's a bash script here to install. So I'll just follow these commands. Open the terminal screen and clone the repository. And now I'll create a folder for hashcat. Okay, so now we need to get OpenCL headers to run hashcat properly. So we'll clone this repository into a new OpenCL directory. Change directory to hashcat and run make command. And it's compiling now. There you go, installation's completed. So let's check with a version parameter. All right, so there's no problem. Okay, so now run hashcat with a help parameter, and we'll have a look at all the available options. I think there's a long help page coming up here, so just wait for a second. All right, so scroll up. So we'll use the M parameter to specify the hash type. Add benchmark to see the available devices on the machine with the different speeds for each hash type. We'll specify the devices that we want to use, separated by commas, with a D parameter. And scrolling down a bit, these are the available hash modes. So we're going to use hash mod number 2500 for WPA cracking. So let's start by running the benchmark. Run hashcat with the B parameter and add the hash mode with the M parameter. And here we have the device list. So the first one is the CPU and the other graphic cards. Here we can see the speed values for this hash mode. And as you can see, the speed of the GPUs is much faster. So let's have a look at KRACK, K-R-A-C-K, or Key Reinstallation Attack. Now, it's a replay attack on WPA2 protocols that secures Wi-Fi connections. So it was discovered in 2016 by the Belgian researchers, and I'm going to slaughter their names, but I'm going to tell you anyway, Matthew van Hoof and Frank Peisens of the University of Leuven. So these attacks can result in the theft of sensitive information like login credentials, credit card numbers, private chats, and any other data the victim transmits over the web. An encrypted WPA2 connection is initiated with a 4-way handshake sequence, although the entire sequence isn't required for a reconnect. But in order to enable faster reconnections, only the third part of the 4-way handshake needs to be retransmitted. So when a user reconnects to a familiar Wi-Fi network, the Wi-Fi network resends them the third part of the handshake sequence. So this resending can occur multiple times to ensure the connection succeeds. So this repeatable step is the vulnerability that can be exploited. So Matthew van Hoof released a script that can be run from Kali Linux to test whether or not your access point, or AP, is affected by this vulnerability. So in this lecture, I will use this script and will test my own device. So I'll go to Kali, open the browser, search crack attack scripts, and the second result is the GitHub page of the script. So we'll click on it, and we'll scroll down a bit. Now, I'll tell you an important note here. These scripts are not attacking scripts, and they are only created to test the devices. All right, so I'm going to start by installing the prerequisites. Open terminal screen, run apt update. Then copy these packages and run. And of course, we have to install these packages with Python 3. All right, so once that's done, let's copy the URL and clone the repository. Change the directory to crack attacks, list files. Now first we'll need to disable hardware encryption using this script and reboot the machine. Now before doing that, don't forget to plug in your wireless adapter. Change directory to crack attack. And here's the script, so let's run it and reboot the machine. Okay, so log in with the default credentials, Kali and Kali. Open a terminal screen and go to the crack attacks folder. And I'll reopen the GitHub page from the browser to check for the next step. So now we need to modify the host APD instance. So we'll change the directory to host APD. Copy the defconfig to the config folder. And type make-j2. Now, before starting testing, we've got to disable the Wi-Fi Network Manager. And to do this, we'll run systemctl stop network manager. All right, so let's have a look at the status of the network manager. And yeah, you can see it's inactive now. So the next step is running the command. So the script can still use Wi-Fi. Go back to the crack attack folder. Run the script. Okay, so this is an important error. So let's try to run it with Python 3. Still not working. So now let's install this module with the pip install command. Run the script. Same error again. Interesting. So let's search. Let's search on Google for this error. And open up this link. All right, so I guess we'll need to install the PyCryptoDomex module, and we'll install it with pip. Now let's run the script again. And there you go, it's ready now. So the script created a fake access point named test network. And the password of this access point is ABCDEFGH. Now let me connect to this access point with my Android phone. And it is authenticated. All right, so now remember that this script tests for key reinstallations in the four-way handshake. It repeatedly will send the encrypted message 3 to the client. And as a result of the test, the client did not reinstall the pairwise key in the four-way handshake. So that's good. That means that my phone is not affected by this vulnerability. Well, look at that. We are here in the last section of the course. And it's a doozy. So WPS stands for Wi-Fi Protected Setup. Yeah, we mentioned it at the beginning, but I want to continue and get into some details. So WPS was designed to make setting a secure access point simpler for the average homeowner. It was first introduced way back in 2006, but by 2011 it was discovered that it had a serious design flaw. The WPS pin could be brute forced rather easily. Now, with only 7 unknown digits in the pin, there are just 9,999,999 possibilities, and most systems can attempt that many combinations in a few hours. So once the WPS pin is discovered, the user can use that pin to find the WPA2 pre-shared key or password. Now, since a brute force attack against WPA2 protected access can take many hours or many days even if this feature is enabled on the AP and not upgraded, it can be a much faster route to getting the PSK. So it's important to note here, though, that the new APs no longer have this vulnerability, since this attack will only work on APs sold during that window between 2006 and, I'd say, early 2012. Now, since many families keep their access points for many years, there are still many of these vulnerable ones around. Now, as I mentioned in the Wi-Fi interaction section, there are 3 primary methods used in Wi-Fi protected setup: pin entry, push button configuration, or PBC, and near field communication, or NFC. So my access point here is using the push button configuration method, so I can just perform a pin attack to the access point. But the attack will fail because I won't be able to set a pin to my access point. First, remember to enable WPS from your modem interface. Now, since the setting can change for each modem, you'll need to go to the interface of your modem and find the WPS section. So let's see how to perform a WPS pin attack with Wi-Fi TE. Go to Kali, open a terminal screen, and let's check the mode of the wireless interface. It's currently in managed mode, so it needs to be placed into monitor mode on the channel number of the access point. Then open Wi-Fi TE from the menu. And here are the options for the WPS attack. Run Wi-Fi TE with a WPS parameter. Then when you see the target access point, just keyboard command Control-C. Select the number of the target access point. And that's all. Wi-Fi TE starts the WPS attack, and it will try to crack the pin with 2 different methods. Now you can see here that my attack failed because there is no pin. If you can activate WPS with a pin method on your access point, you can follow those steps, and you will crack the pin. Cross-site scripting, or XSS, is one of the most common vulnerabilities of web applications. It's caused by improper input and output validation. So generally it happens by including malicious client-side scripts into web pages. And when a victim visits the page or clicks a code-injected link, then the malicious script code is executed. And at this point, the victim's browser has no way to determine whether the script is trusted or not. So it'll just execute the script. And by the execution of the script, it can access cookies or other sensitive information retained by the browser. Such a script can even rewrite the entire content of the HTML document. Now, although XSS attacks are possible in VBScript, ActiveX, Flash, and even CSS, the most used language, of course, is JavaScript. So executing untrusted JavaScript code in browsers can have devastating consequences. Anyway, we can divide XSS attacks into 3 types: reflected, stored, and DOM-based XSS. So in the next few lessons, we're going to cover XSS flaws in detail. So this type of XSS vulnerabilities occur when the malicious input in an HTTP request is immediately returned to the victim's browser in an HTTP response. So the malicious input data is not stored on the back end. So that's why we call it reflected. What the attacker enters is reflected to the victim quickly. Now, it's also known as non-persistent or first order or type 1 XSS. Reflected XSS vulnerabilities require the malicious script to be embedded into a URL. So, as a pen tester, we should try to find a way to entice the victim user to click the link containing the malicious script. Now, in order to be successful, the user needs to click on the infected link. But before that, we need to use whatever social engineering technique we need to deliver the infected link to the potential victims. So, open Kali and log into BWAP, just like we always do. Now, as you can see, there are many examples of XSS vulnerabilities in BWAP, and I'm going to exploit some of them, not all. So let's first choose the XSS reflected get. And it's nothing but this sample page. But what you type in the fields will be reflected to the page. And then the values will transmit over the URL. And view the page source. And here are the values I typed. So this is a suspicious form. Okay, so now let's have a look at the code. Now, here at the beginning, there is a function named XSS, and it calls XSS check 3 and check 4 functions according to the security level. So scroll down a little bit, and it grabs the values in the form, then it uses them in the XSS function. All right, so if the level is low, the values will be printed to the screen directly. If not, XSS check 3 and check 4 functions will be executed for medium and a high level. And this function is in this file. We'll scroll down, and here are the functions. So check 4 uses add slashes function to prevent these characters. And check 3 uses HTML special chars function with encoding. So, go back to Firefox, and I'm going to paste HTML1H1 tag in here, and it's executed. So view the source, and here's the problem. So the input is not sanitized at the back end, and added the source of the page. So, let's look to see, and there's no difference between this tag and any other HTML tag on the page. No encoding or anything else, and this tag is reflected with the page to us again. So now I'm going to paste another HTML tag, and it's here in the source. Okay, so this time I'm going to add this tiny JavaScript code, and it's also executed. So, view the source, and here are the script tags that we sent. And now I'm going to change this JavaScript code a little bit. Then fill in the form and go. And in the message box, we see the cookies and the session ID as well. So, how do we benefit by executing JavaScript in the browser? So, JavaScript provides us the power to do many things browser-side, but we do have to use a browser. So, in order to hack, we need to execute JavaScript in someone else's browser. So, copy that URL and open another tab and paste it and go. So you can see JavaScript payload in the URL is executed as soon as I open the page. Or, in our scenario, clicking a link. So we need to deceive the user to click a link, right? But alerting the session ID is not a good way. So you can use this code. It will send base64 encoded user's cookie to my application. You can download and host it on your Kali or your host if you like. It's a simple Bootstrap 4 app. So paste this payload in here. Open the Web Developer tool, then go. And what do you see? The code is sent to the server, and nothing happens at the back end. But then the JavaScript code is reflected to the page, and then this JavaScript code executes and sends the encoded cookie value to my grab page. So view source. And our payload is perfectly displayed here. So now go to the Cookie Stealer app, refresh the page, and we have an incoming session. So click to log in. Username is awapt, and password is 12345. And the cookie with the session ID is here. Now from the More button, you can view details about incoming requests. You can check to see if the session is live or not. Return to sessions. Also, you can view the main page on BWAP. And as you can see, here's our current user. Okay, then go back to Kali again. And I validated the XSS vulnerability. So now copy this URL, then log out. Open BWAP with just as another user. So I'll log into it as BWAP user 1. And let's say somehow I've sent the link to this user and the user clicks on it. So that means I'm just going to paste it here and hit enter. View source. The value in the URL is lying in the source. Then go to the Cookie Stealer app, refresh the page, and here is a new user's cookie. Now go to session, and it is BWAP user 1 session. So we stole the session ID value of the user, and we'll use it to authenticate ourselves. Good. So let's have a look at some other examples. So BWAP handles different aspects of XSS very well. And the next example is one of them. So after logging into BWAP, choose Reflected JSON from the menu. And there's a search box on the page. So let's examine the page a little bit. So I'm going to type THOR into the box. And yeah, we have that movie. It's a positive result. Now, what I type is also in the URL. The title parameter holds this value. Okay, so now let's view the source. And here's the result. The page sends JSON data. Then this data is parsed and printed to the page. All right, you ready for another? Enter IRONMAN without spaces. And a negative result comes back. But also the data is reflected. And the value is still in the URL. So view the page source again. Now, this is my input, and it is reflected to the page. So like I did in the previous lesson, paste the HTML H1 tag. Okay, it works. And paste the NBA link. Okay, so something went wrong here. Let's view the source. The link is here. Okay, I think I found it. Did you? So the single quotes cause the problem with JSON data. So if I add backslashes before the quotes, it will work. So this problem is solved. Now, before we go any further, I do want to show you the code. So open terminal and just have a look with me. Now here, if the level is low, the title parameter is used as is. If it's not low, it is checked with a function. Then the output is generated, and scroll down. So now here is the script, and the output is added into the script. And then as you see, if the result is negative, the search term is sent back to the browser. So go back to Firefox, and we can run HTML tags entered into this field. So let's paste this tiny script. Okay, no, it doesn't work. So now to figure out what's happening, let's view the source. Because my input breaks the original script, right? Now this part is between script tags. So it can't be executed if there's, anything meaningful. And the rest is not between script tags. So the browser uses the remaining part as text. So it displays text in the page. So now type Iron Man to clear here and view the source. Now we can create our payload, which doesn't break the original script. So I'm going to just write it here, and step by step I will create the payload. So first let's close these double quotes around our input. Then using this curly bracket, and then this bracket, and then this single quote around the JSON data. Then a semicolon to end this line. And close the opening script tag. So now we can start our payload. First alert the cookie as always, and then add an opening script tag. And that's it. So let's copy this payload and paste it in the search box. And yeah, the JavaScript code executes. Now let's view the source to figure it out better. And this is the first part, so it doesn't have any meaning to the page. And then this is our actual payload. And then this part is the remaining code. It also doesn't really have any meaning to the page. Okay, so let's go back to the page. Now we can send the session value to our cookie stealer app, and we have the payload. So I'm going to copy it and add it here instead of the alert code. And then copy this line, open the web developer tool, paste the code into the search box, and go. The requests sent from this page are below. And base64 cookie value is sent to our stealer application. So view the source. So our good payload is lying in the source. So open the stealer app, refresh the page, and the cookie values come up. So now let's go to our session. This is our user, and we are able to send the user session. Okay, so go back to Kali. Now we can use this URL to get any user session. So we can deceive a user to click on a link comprised of this URL. Then get a session. And we've already done that in a previous lesson. So I'm going to leave that for you to do. All right? Now, this type of XSS is the most dangerous one. It occurs when the malicious input in an HTTP request is stored at the back end for later use. So here, the attacker doesn't need to perform any clever social engineering techniques because the malicious script is stored at the back end and then embedded into the pages that are viewed by other users. So the users trust the application and the attacker's script is executed in their browser. It's also known as persistent or second order or type 2 XSS. Okay, so open up Kali, log into BWAP, and open XSS stored blog. And again, it's a sample page. So it looks just like a comment page, and you can add and delete your entries. So let's check in here to show all the entries from the other users as well. And here you can see that comments are listed just like this. So you can view someone else's comments also. Let's view the source page. Doesn't look like there's anything suspicious in the source. And the comments are listed in a table. Okay, so now I'm going to do the same thing that we did for reflected XSS. I'll first try to add HTML tags. So paste HTML H1 tag and submit. And it works. And paste an HTML link and then submit. It also works. Okay, so view page source. Now you see the HTML tags I entered are lying in the source. They are not escaped, not sanitized, nothing else. So now open the terminal to see the code. And this is the code file. Now don't confuse this with SQL